HCF of 50 and 70 by Euclid's division lemma or Euclid's division or simply EDL. So first do normal division. 50 ones are 50. 70 minus 50 is 20. So the same statement we need to write in the form of A equals to BQ plus R. Dividend 70 is equals to divisor into quotient 50 into 1 plus remainder 20. Dividend equals to divisor into quotient plus remainder. This is only A equals to BQ plus R. Now from this line we need to pick 50 and 20, nothing but divisor and remainder. Again these two we need to do division. Let us check. 20 and 50. 22s are 40, 50 minus 40, 10. Again this same we need to write in the form of A equals to BQ plus R. That is nothing but dividend 50 is equals to divisor into quotient 20 into 2 plus remainder 10. Now again same from this line also we need to take the divisor as well as remainder and we need to do the same division again. We need to continue the same process until and unless we get the remainder 0. So 10 and 20. If we do division, 10 2s are 20. So 20 minus 20 remainder is 0. So now write this in the form of again A equals to BQ plus R. That is dividend 20 is equals to divisor into quotient, that is 10 2s are plus remainder 0. So if we observe this, remainder we got as a 0. So as soon as we get the remainder 0, we need to stop this process here. So after getting the remainder 0, and what will be the final divisor, that will become our HCF. So here the divisor is 10. So our HCF will become 10. HCF of 50 and 70 is 10. Next, HCF of 15, 25 by Euclid's division lemma or simply Euclid's division or EDL. First do division of 15 and 25. 15 ones are 15. 25 minus 15. 10 is the remainder. Now write this in the form of dividend is equals to divisor into quotient plus remainder. Nothing but A equals to BQ plus R. So 25 is equals to 15 into 1 plus remainder 10. Now from this one we need to pick the divisor as well as remainder and we need to continue the division process again. 10 and 15. 10 ones are 10. 15 minus 10, 5. This again as usual write in the form of A equals to BQ plus R. That is dividend 15 is equals to divisor into quotient 10 into 1 plus remainder 5. Now again the same process we need to continue until we get the remainder 0. So from this one we need to find pick now divisor 10 and remainder 5. Again do the division of these two. 5 and 10. If we do division, 5 2s are 10 and the remainder is 0. So now write this in the form of again A equals to BQ plus R. So 10 equals to, that is dividend is equals to divisor into quotient, that is 5 times 2 plus 0 remainder. So in this step we got the remainder as a 0. So we need to stop the process here. Now the remainder is 0 and the divisor is 5. So after getting the remainder 0 we need to check what we got the divisor. Here the divisor is 5. So our HCF is 5. Now these two problems you need to solve. Coming to the next topic. Find the HCF as well as LCM of 10, 12 by prime factorization. So for the number 10, let us do prime factorization first of all. That is 2 5s are 10. Next coming to the number 12. 2 6 are 2 3s. So if we write the prime factorization clearly, 10 is equals to 2 times 5, 12 equals to 2 times 2 times 3. Now from this we need to write the HCF as well as LCM. So let us check how to write exactly. First, not to have any confusion, always go with the HCF only, it will be better. Then after you go with the LCM. So now for going the HCF or to find out the HCF, first we need to check the numbers which are common compulsory. Here 2 is there, here also 2 is there. Nothing else is common. Here 5 is there, but 5 is not there anywhere here. Here 2 extra is there, here 2 not there, here 3 is there, 3 not there. So only 2 is common. Then our HCF will be 2. Next, coming to the LCM. Write all the numbers which are common, that is 2, into now the numbers which are all extra, those all numbers also you need to write. Now if you observe that clearly, here 5 is extra, write that 5 here, into here 2 is extra, write that 2, into here 3 is extra, write that 3. So our LCM is 2 into 5 into 2 into 3. So 5 2s are 10, 10 2s are 20, 23 are 60. So LCM of 10 comma 12 is 60. Let us check one more now. What is the HCF and as well as LCM of 15 comma 18 by same process again, prime factorization? So let us do for 15 first of all. 15 is very simple, 3 5s are 15. So 15 is equals to 3 times 5. Next, coming to the second number, that is 18. So for 18 if we do, 18 is equals to 3 times 6, 18, as 6 is a not prime number. So let us continue this again. 3 2s are 6. So now here 18 is equals to 3 is there 2 times. So 3 into 3 into 2. Now let us find out the HCF as well as LCM of these two numbers. First if you go with the HCF, then after I'll come to the LCM. Now first check the common numbers. Here 3 and 3. Only 3 is common. So in HCF 3 will be there. So HCF is 3, finished. Now coming to the LCM. First write the common numbers, that is 3 is common. So write into. Now all the extra numbers we need to write. Here 5 is extra. So write that 5 here. Into. Here 3 is extra. Write that 3 here. Into 2 is extra. Write that 2 also here. So our LCM will be 3 5s are 15. 15 3s are 45. 45 2s are 90. So LCM of 15 and 18 is 90. Now, finding the LCM as well as HCF by prime factorization of these given two sums is your work. Next one. Check whether the given numbers or the following are terminating or non-terminating repeating type of decimal. So how we will decide without doing division whether a given P by Q form number having a terminating decimal or else non-terminating repeating type of decimal? It depends completely on the denominator. If the denominator is in the form of 2 power n into 5 power m. If the denominator is in the form of 2 power n into 5 power m, then we can say that the P by Q number or else the rational number has terminating decimal. In case if it is not in the form of 2 power n into 5 power m, then it has non-terminating repeating type of decimal. So what exactly this 2 power n into 5 power m means? In the denominator, after doing the prime factorization of the denominator, the number should be only 2 or else only 5 or else 2 and 5. If it is like this, I mean if the denominator is in this form, then we can say that it has terminating decimal. Whatever it may be the power. Here 2 power 2 bill should be there, no problem. 2 power 100 should be there, no problem. 5 power 1000 should be there, no problem. 2 power 2 and 5 power 4, whatever it may be the power, we need not to worry about the power, only we will worry about the base. If the base is 2 or else 5 or else 2 and 5 both, if this is the base in the denominator, then we can conclude that it has terminating decimal. Except these numbers, if any other number is there, then it has non-terminating repeating type of decimal. So let us check one by one now. 22 by 7 if you observe now. Here the denominator is a 7. 7 if you do prime factorization it is 7 only because already the 7 itself is a prime number. So it is not possible to simplify the denominator further. So this is not in the form of 2 power n into 5 power m. So this is non-terminating repeating type of decimal. Coming to the next one, 4 by 5. Here the denominator is 5. As we discussed, if the denominator is in the form of 2 power n into 5 power m, obviously it is in the form of 2 power n into 5 power m. So this is terminating type of decimal. Next, coming to the third one, 33 divided by 14. So before going to any conclusion in this kind of questions, we need to make sure that whether any cancellation or simplification is possible or not possible. So here if you observe this, 11 3s are and 11 4s are. So cancellation is possible. I did that one. Now after doing simplification, we got the numbers 3 divided by 4. As I said already, we need to write the denominator as a prime factors, or else doing prime factorization. Simply I can say 3 by 4 can be written as 2 square, or else 2 into 2. So if we observe this denominator base, so that is 2. Yes, then obviously this is terminating. Next, coming to this, 11 by 5 into 2 into 3. 5 is there in the denominator, which is want. Okay, very good. 2 is necessary for us, so it is there. Okay, very good. But some other number, unnecessary number 3 is there. So that is the reason this is non-terminating repeating type of decimal. Next, coming to this last one, 14 by 100. Obviously, in the denominator, if 10, 100, 1000, 10,000, these kind of zero numbers are there, means it is very easy to write the decimal. But how to do this exactly then? 100, do prime factorization for that. 2 times 50, 2 times 25, 5 times 5. So 2 power 2 into 5 power 2, right? So 14 divided by 2 is there 2 times, so 2 square, into 5 is there 2 times, so 5 square. Now if we observe this denominator, I mean basis of the denominator, here base is 2, here base is 5. So the denominator is only having 2 and 5, no other unnecessary numbers. So it is terminating type of decimal. Now you heard some of the problems, right? So based on that logic, you do for these two and check whether these two numbers are terminating decimal or else non-terminating repeating type of decimal. In the previous questions, we did whether it is a terminating decimal or else non-terminating repeating type of decimal. Then if it is a terminating decimal, then how to find out that decimal, that too without doing the division. This is one of the compulsory questions in the exams. Almost every time they will be asking this kind of questions, that is finding the decimal of a given p by q number without division. Just keep that in mind, without division. So it's very simple. First, make sure that the denominator is in the simplest form or not. That is nothing but writing the prime factorization. Here if you observe the question, 22 divided by 5. 22 by 5, it is already in simplified form only because 5 is a prime number itself, so no problem with the denominator. Now just simply multiply and divide this number by 2 by 2. Why only this 2 by 2 means here 5 is there, that 5 is nothing but 5 power 1. So 5 power 1 is there in the denominator, means you need to multiply and divide with 2 power 1. 2 power 1 is as usual as 2. If 5 square is there, you multiply and divide with 2 square. If 5 power 4 is there, you multiply and divide with 2 power 4. If 5 power 100 is there, you multiply and divide with 2 power 100. The same in reverse also. If 2 power 4 is there, you multiply and divide with 5 power 4. If 2 power 7 is there, you multiply and divide with 5 power 7. The same continues. So now 22 into 2, 44, divided by 5 into 2, 10. 44 by 10, 4.4. So 22 by 5 value is exactly equals to 4.4. Now in this case, we didn't do any actual division anywhere. That is long division, right? We didn't do that long division ever. Next one, 7 by 2. So here if you observe in the denominator, 2 is there, nothing but 2 power 1. So we need to multiply and divide with 5 power 1. Simple 5. 7 5s are 35 divided by 2 5s are 10. So 35 divided by 10, 3.5. Next, 7 by 50. Here 7 by 50 is not a prime number. So we need to do prime factorization for that. Let us check once. 5 tens are 5 twos are. So here 50, if you do prime factorization, 5 is there 2 times and 2 is there 1 time. So 5 is there 2 times, right? So 5 square into 2 is there only 1 time. So 2. 5 square into 2. Now what number we need to multiply with? Here 5 is there 2 times. 2 is there only 1 time. So it means one more 2 is required for us. So that is the reason multiply and divide with 2 only. No need to take anything else and no need to worry about anything extra. So 7 into 2, 14 by. Here 5 is there 2 times already. 2 is there 1 time here and 2 is there 1 time here. So it means 2 is there also 2 times. So that can be written as 5 square into 2 square. So if we simplify this, 14 divided by 5 square into 2 square, it is 10 square. That is 14 by 10 square. 10 tens are 100. What is the value of 14 divided by 100? It is 0.14. Now find out the decimal for these two numbers without actual division. Next, one of the important type of questions is checking whether the given number is a composite number or not. First of all, before going to that, what exactly a composite number means? If a number has more than two factors, what are those factors? 1 and the number itself. If any number has more than these two factors, then that number is considered as a composite number. For example, if we take a number 4, what are the factors of 4? 4 will come in 1 table, 4 will come in 2 table, 4 will come in 4 table. So now these are factors. How many are there? 1, 2, 4. 3 factors are there. So this number 4 has more than 2 factors. So this 4 is considered as composite number. So for any number, if more than 2 factors are there, means it is considered as a composite number. So now this question, 2 into 3 into 4 into 5 into 6 plus 3. In this total, plus a symbol is not there. So it is considered as single term. And this side, one number is there. This is considered as one term. So total 2 terms are there. Always the terms will be separated with plus or minus symbol only. So total 2 terms are there. Now in the first term as well as in the second term, if we observe clearly, something will be there in the common. That is compulsory. Either one number or 2 numbers or sometimes 3 numbers also, whatever it may be. But definitely in the first term as well as in the second term, compulsory one number will be common. So not to do any mistake in the next step, I will do a small modification in this question. First term I will write as it is plus. The second term 3 is there, right? That 3 I am writing it as 3 into 1. Why I am writing that, you will get to know in the next step clearly. Now this first term and second term, if you observe clearly, the number which is common here is number 3. So take that 3 common. Now here you can keep the square bracket or else parenthesis, it's up to you. This 3, if we take outside, then what else we remained with? Here 2 is remaining, 4 is remaining, 5 is remaining, 6 is remaining. All these numbers are multiplied. So do the same here also. Now 3 I already wrote outside anyway, right? So remaining are 2 into 4 into 5 into 6. After finishing this, here we have plus symbol. So keep that plus symbol as usual. Now in the second term, number 3 completed, then number 1 is remaining, right? So write that number 1 here. This is the reason I said you to write the given question as small modification as 3 into 1. Because what some of the students are doing here mistake is 3, if they are not writing it as 3 into 1, simply they are taking number 3 as common. Here after taking 3 common, nothing is remaining. So they are completely avoiding that one. So that is the mistake most of the students are doing. So no, to avoid that kind of silly mistake, it is better to write just a number 3 as 3 into 1, whatever it may be. If only single number is there, means write it as into 1. Into 1 means nothing will happen anyway. So we will get to know also something is extra there, so that we will write in the next step. Now 3 times Just multiply all these numbers. 2 4s are 8, 8 5s are 40, 46 are 240 plus 1. 3 into 240 plus 1, 241. 3 times 241, 3 ones are 3, 3 fours are 12, 2 1 carry, 3 to 723. So 723, then 723 is a composite number. If it is a small number means easily we can able to say it is a composite number or else prime number or else something else. But in this case, is it possible to say it is a prime number or composite number? Yes, it is possible, because based on the logic that if a number has more than two factors, then it is a composite number. Now, for example, if we take this number here, 723. For 723, 1 is a factor, definitely. And for 723, 723 is also a factor. Yes. Then what is one more extra factor it has? If you observe the previous step, we will get to know. 3 into 241. If we are multiplying 3 with 241, then we are getting 723. So 240 is considered as factor. The same way 241, if you multiply with 3, we are getting the answer 723. So 3 is also one of the factors. So here only we can able to see 4 factors. So definitely we can say very clearly that 723 is a composite number. Coming to one more question. 7 into 6 into 5 into 4 into 3 plus 4. Here after the plus symbol only a single digit is there. So not to have any confusion, that 4 I am writing it as 4 into 1. Finish. Don't write it as anything else, because if you write 4 into 2 or 4 into 3, the value will change. 4 into 1, 4 only. So no value will change. That is the reason only you need to multiply with 4 only. Now if we observe this total first term and else this second term, in the first term as well as in the second term, is there any number common we can observe? Yes, obviously, that is number 4. Number 4 is common in both the first term as well as in the second term. So now what we need to do is taking 4 common. Then after taking 4 common, what else we remains with? Here 7 is remaining, 6 is remaining, 5 is remaining, 3 is remaining, with all the multiplication symbol. So write the same as usual here. 7 into 6 into 5 into 3. Then after this plus symbol is there, so write the plus symbol. Now from the second term, 4 we took already common, right? So remaining is 1. Write that 1 here. Now again as usual, do the multiplication. 4 times 7 6 are 42. 42 into 5 3 is 15. So 42 into 15, it is 630 plus 1. Now if we calculate this, 4 times 630 plus 1, 631. So what is the value of 4 into 631? 4 ones are 4, 4 is 12, 2 1 carry, 4 6 is 24, 25, 2524. Then sir, is this 2524 composite number? Definitely yes, because here if you are multiplying two numbers, then definitely this will become one of the factors as well as this will become one of the factors. So here 4 and 631 both are factors, then 1 is a factor compulsory and the number itself is a factor. So 4 factors are there minimum. It means more than 2 factors are there. So definitely this is a composite number. So 2524 is a composite number. Then coming to your part, that is your task. I gave here 2 numbers, so you need to find out whether these 2 numbers are composite numbers or else not composite numbers. Next question. What is the last digit of 6 power 125? Here it may be 6 power 125 or 6 power 1000 or 6 power 1 crore also. The same question they will ask almost every time. So let us check what is the logic behind this. 6 power 1. So 6 power 1 is 6. 6 power 2. 6 square is nothing but 6 into 6, that is 36. Next, 6 cube. 6 cube means 6 is 3 times, right? So 6 into 6 into 6, that is 216. Then coming to the next 6 power 4. So 6 power 4 is 6 into 6 into 6 into 6. 6 we need to multiply 4 times simply. So here 6 6 is 36, 36 is 216, 216 into 6 1296. Now let us check whether we got any pattern here or not. If not, then only I will go with the next step, otherwise I will stop it here only. Last digit is 6, last digit is 6, last digit is 6, last digit is 6. So I got one pattern or else some logic I got here. So 6 power anything, I mean 6 power any number is always ends with the digit 6 only. So it means the last digit of 6 power 125 is 6. Next. This is your task. Then what is the last digit of 5 power 72? You also do steps, 2 or 3 steps, and then after confirm what is the last digit of it. Next, one more question related to this digit type of question. Can 6 power n end with the digit 0? This statement you need to remember here. To be end with digit 0, it should have 2 and 5 as factors. If a number has 2 as well as 5 as factors, then only it will end with the digit 6. So let us check whether the given question has 2 and 5 as the factors or not. So the given number is 6 power n. Here 6 can be written as 2 3s because 6 is not a prime number again. So that's why I'm doing the prime factorization of it. 6 can be written as 2 into 3 whole power n as usual. According to the definition, 2 into 5 should be there compulsory. But here 2 is there but 5 is not there. So as 5 is missing, right? So as 5 is not a factor, as 5 is not a factor, 6 power n won't end with the digit 0. Next question. Can 20 power n end with the digit 0? So same concept we need to follow again. So 20, let us do the prime factorization of this. 2 into 10 power n. 2 into, again 10 is not a prime number, so 10 can be written as 2 5s whole power n. So if we observe this, here 2 is there, I mean 2 is a factor, 2 is a factor, 5 is a factor. 2 as well as 5 both are factors, as 2 and 5 are factors, then 20 power n will end with the digit 0. Then it's your work now. 15 power n, whether it will end with the digit 0 or not. 25 power n, whether it will end with the digit 0 or not. Next, one more type of question which is related to the same digit question only. How many digits will be there in 4 power 1000? You should not get confused related to these kind of questions. Be careful with these kind of questions. Observe this, 3 types of questions total. Here first one, first type of question, what is the last digit? Only the last digit he is asking. What is the last digit? Then second type of digit question is, can some number will end with the digit 0 or not? In the first question, what is the last digit? In the second question, whether the last digit will be 0 or not. And this now coming to this third type, how many digits will be there? For example, if this question is 4 power 1000, right? So 4 power 1000 means 4 multiplied, 4, we need to multiply 1000 times. 4 into 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 1000 times. If we multiply like that, we will get some final answer. In that final answer, how many digits will be there? So that is the answer. So for this question only, he will give one more value also, that is log 2. related to that question they will give this log value also. Just always keep that in mind. In the question, if you get number 3, they will give log 3 value. In that question, if it is their chances to get number 5, they will give log 5 value. So in this question we will get the number 2, so that is the reason they will give it as log 2 value only. So the if log 2 is equals to 0.3010, then how many digits will be there in the 4 power 1000? So take the number 4 power 1000. Here log 2 value is given, right? So what we need to do is base we need to change to 2. So here 4 is the base, right? Write that 4 as 2 square power 1000 as usual again. So now what will be the value of 2 power 2 whole power 1000? That is 2 power, multiply both the powers, 2 into 1000, 2000, 2 power 2000. Now for this value 2 power 2000, you apply the log. So log 2 power 2000. In the logarithm, if the power is for the main number, it will go to the front as it is. So this 2000 will come to the front. So that will become now 2000 into log 2. 2000 into, what is the value of log 2? That is 0.3010. Just simply multiply these two numbers. 2 1s are 2, 2 0 2, 602. 602, 4 zeros, 4 zeros means after decimal 4 digits are there, so only 602 will come. 602. Now this 602 also can be written as 602.0, right? Why I am writing this 0.0, I will say now. 2000, if you multiply with 0.3010, we got the answer as 602. This 602 I am writing it as 602.0. Almost in many cases you will get one decimal number only compulsory. In this case you didn't get. Of course, if you didn't get also, you write it as just 0.0, no problem at all. Now before the decimal, which number will be there? Here before the decimal 602 is there, right? So for that number you need to add plus 1 compulsory. Don't forget this. So you will get the answer 603. So if you expand this 4 power 1000, you will be having 603 digits. Next, coming to the next question, how many digits will be there in the 2 power 25? The same value again. If log 2 is equals to 0.3010, sorry, 2 power 25. Here they gave log 2 value. Here base is 2 only, so no problem. Nothing is there to change. Directly you can apply log for this. So if we keep log for this, log 2 power 25. In the log, if the power is for the main number, it will come to the front as it is. So we will get it as 25 times log 2. 25 into log 2 value is 0.3010. So that is 7.525. Now after finding this value, don't forget that take the number which is before the decimal, that is 7, and add 1 for that. 7 plus 1, 8. So in the expansion of 2 power 25, total 8 digits I'm sorry, total 8 digits will be there. And now you need to find out how many digits will be there in these numbers, that is 8 power 10 and 2 power 14. Next, use division algorithm to show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. In this kind of questions, here sometimes they will ask odd number, or else sometimes they will ask you even number, and sometimes they will ask square of the number, and sometimes they will ask cube of the number. Whatever they are asking The process is same. So let us check what exactly. In this kind of questions, writing the statement or writing some sentences before starting the answer is compulsory. So don't forget that ever. So what is exactly that statement is? Let A be any positive integer. Any positive integer. Let A be any positive integer and B equals to, this B value will be given in the question itself but indirectly. 6q plus 1, 6q plus 3, 6q plus 5. Before the alphabet q, which number will be there? That is nothing but B. That is divisor. So 6 here. And B equals to 6. So if B equals to 6, then what are the possible reminders? Always the reminder will be starting from 0 and it will be less than the divisor. Here the divisor is 6, right? So it should be less than 6. So 0, 1, 2, 3, 4, 5. If the B value or else the divisor is 6, then the possible reminders are from 0 to 5. Now this reminder as well as the divisor value we need to substitute in our formula. A equals to BQ plus R. A equals to BQ plus R. So A equals to, B value 6, right? So 6Q plus remainder 0. Then A equals to 6Q plus, here first remainder complete, next one remainder is 1. A equals to 6Q plus 1. The same way A equals to 6Q plus 2. Then A is equals to 6Q plus 3. Then A equals to 6Q plus 4. A equals to 6Q plus 5. Finished. All the possible reminders I substituted. Now let's go back to the question again. He is saying only about the odd integers, right? So let us pick what are odd in this and what are even in this. Here 0 is the remainder, so it will become even. 1 is the remainder, odd. 2 is the remainder, even. 3 is the remainder, odd. 4 is the remainder, even. 5 is the remainder, odd. So it means we need to confirm the final statement as every positive odd integer is of the form 6q plus 1, 6q plus 3, 6q plus 5. Finished. If a square is there means again for this values only we will do squares. If cube is there means for that values only we will do cubes also. I will say that also. Okay, check here now. Use division algorithm to show that square of any positive integer is of the form 3p or 3p plus 1. First statement compulsory. Let A be any positive integer and B is equals to 3p plus 1. So B value will be 3. Then if B value is 3 means then what are the possible reminders? So the possible reminders always start from 0 and less than the divisor. Here divisor is 3, so less than 3. 1, 2. So the possible reminders are 0, 1 and 2. Now let us write this in the form of A equals to BQ plus R. A equals to BQ plus R. So A is equals to, B value is 3, Q plus first remainder is 0. Now in the previous question they asked about only odd and even or something like that, then we closed there only. But in this question they are particularly asking about the square of the number, so we need to do squaring also. That is the reason I'll continue this still. A equals to 3q plus 0, nothing but 3q. Now doing squaring on both the sides, because in the question it is clearly mentioned that square of any positive integer. So that is the reason we need to do squaring. A square is equals to 3q whole square. So 3q whole square, 9q square. Now come back to the question again. 3p plus 1. So 3 is the divisor, right? That is the reason you need to take 3 only common here. From 9q square, if we take out 3 common, what we remains with then? 3q square. So now this we can compare with, this is in the form of 3p, where p is equals to 3q square. What will be there in the bracket? That all you compare with p. That's it. First reminder completed. Now coming to the second reminder. What is the second reminder we have? That is 1, right? So let us substitute 1. A equals to 3q plus 1. As usual, doing squaring on both the sides. A square is equals to 3q plus 1 whole square. So 3q plus 1 whole square. This is in the form of a plus b whole square. So if we expand it, a square plus b square plus 2 into a into b. 3q whole square, 9q square plus 1 square, 1 plus 2 into 3q into 1, 6q. Now from this also we need to take 3 as common, right? From 9 we can take out 3 common, from 6 also we can take out 3 common, but from 1 we cannot take 3 as common. So that's why I will write this 1 at last and remaining 2 at a time I'll write. 9q square plus 6q plus 1 I am writing at last. Nothing value changed. Now from 9q square and 3q I am taking 3 common. So if we take out 3 common, 3 3s are 9 and 3 2s are 6 plus 1 as usual. So now this is in the form of 3. As I said already, this bracket 1 just compare with p plus 1. So it is in the form of 3p plus 1, where p is equals to 3q square plus 2q. 0 remainder completed, 1 remainder completed. Now let us check the 2 remainder. A equals to bq plus r, right? So a is equals to b value is 3, q plus 0 remainder completed, 1 remainder completed. Now coming to the 2 remainder. Again same process, squaring on both the sides. So what it will become then? A square is equals to 3q plus 2 whole square. So 3q plus 2 whole square, again it is in the form of a plus b whole square. So if we expand it, a square plus b square plus 2 into a into b. Sorry. 3q whole square, 9q square plus 2 square, 4 plus 2 3s are 6, 6 2s are 12q. Now from 9 we can take out 3 common, from 12 also we can take out 3 common, from 4 we cannot take 1 common. But here one more thing we can observe clearly, the divisor is 3, otherwise b value is 3. If the divisor is 3 means the remainder should be compulsory less than 3 only, but here the remainder is 4. So one more small modification we need to do here, that is 9q square as it is plus 4 you write it as multiple of 3 plus some other number. So 4 can be written as 3 plus 1 plus 12q as it is. Now if you observe, from 9 we can take out 3 common, from 3 we can take out 3 common, from 12 also we can take out 3 common. This 1 I will write last as usual. So if we take out 3 common, then we remains with 3q square plus 1 plus 4q. This last plus 1 as usual again. So now it is in the form of 3p plus 1, where p is equals to this total bracket. The same type of question only they will ask sometimes in cube also. So instead of square, you do cube. That's it. Next, write 0.3 bar in P by Q form. If in the rational numbers, we will be having two types of questions, decimals, right? One is a terminating decimals and one is non-terminating repeating type of decimal. How to find out P by Q form of a terminating decimal and how to find out for non-terminating decimal, we will check once. 0.3 is there, for example. Now no bar, no dashes, nothing here. So 0.3 is a terminating type of decimal. This is terminating type of decimal. So how to find out the p by q form of terminating decimal? Simply remove the decimal and write the number. If we remove the decimal, it will become 03 by keep 1. After the decimal, how many digits are there in the question? Here is the decimal. So after the decimal, only single digit is there. So write 10 here. After the decimal, if 2 digits are there, means 2 zeros you keep. If 100 digits are there, means 100 zeros you keep. That's it. This is converting a terminating decimal to p by q form. Now coming to our question. Write 0.3 bar in p by q form. So 0.3 bar is nothing but 0.333 and so on. It means the digit 3 is repeating continuously. So this kind of decimals are non-terminating, repeating type of decimal. So the given question only you take it as x and make it equation 1. So x is equals to 0.333 and so on. Now, after the decimal, how many digits are repeating? The same number you need to multiply with. Here, 3 is repeating, that is only 1 digit. So, 1 digit is repeating, that's why multiplying equation 1 by 10. If 2 digits are repeating, you multiply with 100. If 3 digits are repeating, you multiply with 1000. If 4 digits are repeating, you multiply with 10,000 and continue like that. Now, first equation we are multiplying with 10. This is left side of the equation, this is right side of the equation, right? So left side of the equation, first let us multiply with 10. 10 into x is equals to. Now let us multiply the right side equation, right side of the equation by 10. 10 into 0.33333 and so on. 10 into x, 10x is equals to, here 0.33 and so on, you are multiplying with 10. 10 has only 1 0. So this decimal will move 1 digit right side. If 100 we are multiplying with, then the decimal will move 2 digits right side. If we are multiplying with 1000, the decimal will move 3 digits right side. So then what it will become now? 3.33333 and so on. This you make it as equation number 2. Now we need to do subtraction of equation number 2 and equation number 1. So equation 2 minus equation number 1. So what is equation 2 we have here? As usual, 10x is equals to 3.33333 and so on, and equation 1 is x is equals to 0.3333 and so on. Let us do subtraction of this. 3 minus 3 0, 3 minus 3 0, 3 minus 3 0, 3 minus 0, under the dot keep dot only. 3 minus 0, 3. 10x minus x, 9x. Now here this is the decimal. After the decimal, these all are zeros only. After the decimal, only zeros doesn't have any value. So you can remove these decimals clearly. So then you will get it as 9x is equals to 3. So we need to find out the x value, then take 9 this side. So it will become x is equals to 3 divided by 9. 3 ones are 3 3s are. So x value is equals to 1 by 3. What exactly this x means? X is nothing but the p by q form of 0.3 bar. Now your work is this one. Find or write 1.45 bar in p by q form. Next questions. Show that root 2 is an irrational number. This kind of questions we are going to solve with one kind of method. That method is nothing but contrary method or else method of contradiction. On the contrary, let us assume if root 2 is rational means definitely we can able to write that in the form of p by q, right? So root 2 is equals to p by q. Actually our textbook is following a by b, that is the reason I am also writing that a by b only. If you write p by q also, nothing will happen. Then what is the condition for these rational numbers then? A comma b both belongs to integers and denominator, that is b not equals to 0. And besides these two conditions, we need to write one more condition, that is a comma b both are co-primes. A comma b are co-primes. What exactly these co-primes means then? A and B both are having only 1 as common factor. Okay, now let us continue our process. So do squaring on both the sides. So it will become root 2 whole square is equals to a by b whole square. Left side, this square root and square both will get cancelled. Then we remains with number 2. So 2 is equals to a by b whole square. A by b whole square nothing but this square is applicable for the numerator as well as for denominator also. So a square by b square. Now take this b square to the left side. So it will become 2b square is equals to a square. Now bring this 2 to the right side. Then it will become b square is equals to a square by 2. So what exactly this a square by 2 means? A square by 2, if we make it into the statement form, 2 divides a square. 2 divides a square. So if 2 divides a square, then 2 divides a also. 2 divides a. 2 divides a, that can be written as a by 2. So if 2 is dividing a, then definitely it leaves some answer, right? That answer I don't know, so that's why I'm making it equals to some constant c. You can make it any alphabet, no problem. Now take this 2 to the right side. So a is equals to 2c. This a value we need to substitute in this equation, that is 2b square equals to a square, right? 2b square is equals to a square. 2b square equals to, here only I got a value as 2c. So here in the place of a, I am substituting 2c whole square as usual. Now 2b square is equals to, what is the value of 2c whole square? 4c square. 2 1s are 2 2s are. Then we remains with b square is equals to 2c square. Now take this 2 to the left side. So we will get b square by 2 is equals to c square. Then what this exactly b square by 2 can be read as? 2 divides b square. If 2 divides b square, then 2 divides b also. Now if we observe from here, 2 divides a and here 2 divides b. So from these two I can conclude one thing, that is 2 divides a and b. If 2 divides a and b means compulsory 2 is one of the factors. But at the beginning I took one condition, that is a comma b both are co-primes. It means no other common factor except the number 1. But here 2 is the common factor. So you need to conclude it as it contradicts. It contradicts the fact that a comma b are co-primes. So that is the reason root 2 is root 2 is an irrational number. Next question. Show that 1 by root 2 show that 1 by root 2 is irrational. First statement as usual, on the contrary, let us assume 1 by root 2 is rational. So 1 by root 2 is rational means we can write it as 1 by root 2 is equals to a by b, and the conditions comes are a comma b belongs to integers and b not equals to 0, then a comma b are co-primes. Here no need of doing any squaring, nothing. Simply reciprocate the total equation. 1 by root 2 will become root 2 by 1. A by b will become b by a. Whenever you are doing reciprocal, you need to do the complete equation, not only left side, not only right side. So 1 by root 2 I reciprocated and we got it as root 2 by 1, and a by b we got it as b by a. So now left side part, if you observe, root 2 by 1, root 2 by 1 is as usual as root 2. So root 2 is equals to b by a. Now go back to the conditions. A comma b both are integers, right? So it means in the place of a, in the place of b, whatever the number you substitute, also this always will be a rational number only. But left side part, if we take root 2, that is irrational. Is there any chance that a rational number is equals to irrational number? It's impossible case. So that is the reason right side what we need to write it is as a comma b are integers, RHS is a rational number, whereas LHS is an irrational number. We got this contradiction due to our wrong assumption. So 1 by root 2 is an irrational number. Next, show that 2 plus root 3 is a rational number. First, as usual, the same statement. On the contrary, let us assume that 2 plus root 3 is rational. So if it is rational means we can able to write it in the p by q form, right? So 2 plus root 3 is equals to a by b. Condition, a comma b both belongs to integers, b not equals to 0, a comma b are co-primes. Here also no need of any squaring, nothing. Now simply take this 2 to the right side. So it will become root 3 is equals to a by b plus 2. If we take another side, it will become minus 2. Root 3 is equals to, this 2 can be written as 2 by 1. Now do LCM to the right side. B into 1b, a into 1a minus b into 2, 2b. Cross multiplication I am doing actually here. B into 1b, a into 1a, b into 2, 2b. That's it. Nothing but you can say it as a LCM also, whatever you call it as. Now observe the left side part clearly. A is an integer, B is an integer, and B is an integer. As A comma B are integers, RHS is a rational number, root 3, but LHS is an irrational number. We got this contradiction due to our wrong assumption. So 2 plus root 3 is an irrational number. Next question. Show that 2 plus 2 root 3 is an irrational number. So first statement as usual, on the contrary, let us assume that 2 plus 2 root 3 is a rational number. So 2 plus 2 root 3 is equals to a by b. Conditions as usual, a comma b are integers, b not equals to 0, a comma b are co-primes. Now here also no need to do any squaring, nothing, just simply take this 2 to the right side. So it will become 2 root 3 is equals to a by b minus 2. This 2 can be written as 2 by 1. So 2 root 3 as usual is equals to right side, do the LCM of it. B into 1b, a into 1a minus b into 2, 2b. Now in the next step, to this 2 also, this side, here left side it is multiplication. If you take to the right side, it becomes division. So root 3 is equals to a minus 2b by 2b. Now coming back to the same sentence. A comma b, as a comma b both are integers, the RHS is a rational number whereas LHS is an irrational number. This contradiction has arisen due to our wrong assumption. So the given question is a irrational number. Now for this kind of question, that is, show that root 2 plus root 3, here root 2 is a irrational number as well as root 3 is irrational number. Both are irrational numbers. Now we need to do squaring on both the sides for this kind of question. So let us check how to do this one then. First statement as usual, that is, on the contrary, let us assume that root 2 plus root 3 is a rational number. So now next step will be root 2 plus root 3 is equals to a by b. Here condition must and should a comma b are integers, b not equals to 0, a comma b are co-primes. Now do squaring on both the sides. What that will become then? Root 2 plus root 3 whole square is equals to a by b whole square. Now if you observe this left side part, that is root 2 plus root 3 whole square, it is in the form of a plus b whole square. So this a plus b whole square we need to convert as a square plus b square plus 2ab. So that will become then root 2 whole square plus root 3 whole square plus 2 into root 2 into root 3 is equals to, this square is applicable for the numerator as well as for the denominator. So then it will become a square by b square. Left side square root cancel, square root cancel. So then we remains with 2 plus 3 plus 2 into root 2 into root 3 root 6 is equals to, right side part as usual, a square by b square. Now left side 2 plus 3 5 plus 2 root 6 is equals to a square by b square. From here onward same like the previous questions. Take 5 to the right side, so we remains with 2 times root 6 is equals to a square by b square minus 5. This 5 can be written as 5 by 1. 2 root 6 is equals to a square minus 5b square divided by b square. Now take this 2 also to the right side. Then finally we remains with root 6 is equals to a square minus 5b square divided by 2b square. Now same sentence as usual. As a comma b are integers, the RHS is a rational number but LHS is an irrational number. This contradiction has arisen due to our wrong assumption. So the given question is an irrational number. Now these 5 questions you need to solve. Show that root 5 is an irrational number. Show that 1 by root 5 is an irrational number. Show that 2 plus root 5 is an irrational number. Show that 2 plus 2 root 5 is an irrational number. Show that root 3 plus root 5 is an irrational number. So in these 5, this one, root 3 plus root 5 and root 5. For these 2 questions only squaring on both the sides is necessary. For remaining all, just take from left to right and solve it. Finish. Now coming to the last topic of the chapter real numbers, that is logarithms. In this the question is converting exponential form to logarithmic form and logarithmic form to exponential form. Very few students will concentrate on this one, so you don't miss this. Converting exponential form to logarithmic form, or else in reverse logarithmic form to exponential form. So let us observe this one. 2 power 5 equals to 32. This is now in exponents and powers. So exponential form. This exponential form now we need to convert it to logarithmic form. Then how to convert that? Simply for the answer keep log 32. This power you write it as the answer here is equals to 5. Now observe this total question. 2 power 5 equals to 32. Number 32 completed, number 5 completed, then remaining is base 2, right? Here also you write it as the base only. Finished. Converting from exponential form to logarithmic form. 2 power 5 equals to 32, that is converted as log 32 base 2 equals to 5. Just one thing, always keep it in mind, here the base is 2, here also same base will be there. Now let us check in reverse then, that is converting from logarithmic form to exponential form. Same question I am taking, not to have any confusion. Log 32 base 2 is equals to 5. This is in logarithmic form right now. This logarithmic form we need to convert to exponential form. This is log, this will become main number. So write the main number is equals to, this is base, right? This you write it here also as the base only, and this extra number you write it as the power. Finish. So 32 is equals to 2 power 5. Converting exponential form to logarithmic form and logarithmic form to exponential form. It will be helpful mainly in the objective, that is part B. So you try these two. First one is exponential form, you need to convert to logarithmic form. Second one is logarithmic form, you need to convert to exponential form. Next, how to find out the value of the logarithms. Find the value or compute or calculate or evaluate log 25 base 5. So how to do this? Log 25 base 5. Observe this clearly. Log 25 can be written as 5 square, base 5 as it is. In the logarithm, if the power is there for the main number, that power will go to the front as it is. So 2. Remaining log 5 base 5. This 2 as it is into the value of log 5 base 5 is 1. So 2 into 1, 2. Not only log 5 base 5, any same number and base is there means in logarithm answer is 1. Log 10 base 10, 1. Log 2 base 2, 1. Log 7 base 7, 1. Log 100 base 100, 1. Log 9 base 9, 1. Except log 1 base 1. Log 1 base 1 is not defined. That's, you keep it in mind. Next. What is the value of log 5 base 25? Log 5 base 25 is there, right? The 25 can be written as 5 square. Now if you observe the difference between the previous question and this question, in the previous question the power is for the main number, whereas in this question the power is for the base. So if the power is for the base, it will go to the front as the reciprocal. Here number 2 is there, right? If it goes to the front, it will become reciprocal. So 2 reciprocal is 1 by 2. Remaining all as usual, log 5 base 5. So this is 1 by 2 into the value of log 5 base 5 is 1. So 1 by 2 into 1, 1 by 2. Next, let us check one more. Log 81 and base 27. Log 81 can be written as 3 power 4. 27 can be written as 3 power 3. Now here, this power is for the main number, so it will go to the front as it is, 4. This power is to the base, then it will go to the front as the reciprocal by 3. Then remaining will be log 3 base 3. So 4 by 3 into this value log 3 base 3 is 1, right? So 4 by 3 into 1, that is 4 by 3. Next question, expanding the logarithms, otherwise making it as a single logarithm. Log 30 can be written as 3 tens. In the logarithms, multiplication will become plus, plus becomes multiplication, division becomes minus, minus becomes division. Just keep these 4 operations in your mind. If multiplication is there means the next step we will write it as the addition. If addition is there means we will change that to multiplication. If minus is there means division. If division is there, means minus. That's it. Now in this case here we have multiplication, right? So multiplication will become addition. So log 3 into 3 into 10 can be written as log 3 plus log 10. You may get the doubt, why I am not writing this 10 as 2 5s are then? Here some logic is there. For any logarithm, if the base is not given, always the base will be 10. Just keep that in mind. So now log 3 base 10 value we don't know, so as it is you write. Plus, then what is the value of log 10 base 10? 1. That is the reason I wrote it as just log 10 only. I am not changing to anything else. Next, 2 log 3 plus 4 log 2 minus 2 log 2. Now this is a big one. This we need to make it into small. So the question they will give it as, write it as a single logarithm. So here front number is there, means it will go as the power for the main number. Here front number is there, it will go as the power for the main number. This will go as the power for the main number. So let us check once. Log 3 square plus log 2 power 4 minus log 2 power 2. Log 3 square, 3 3s are 9, plus log 2 power 4 16 minus log 2 square 4. Now if we observe this clearly, the first term and second term, this first term and second term both are separated with plus, right? So in the logarithms, if plus is there, means what we need to do? Multiplication. Log 9 into 16 minus as usual log 4 as usual. So now log 9 into 16, 144 minus log 4 as it is. Then what we need to do? If minus is there in the logarithms, we need to do division. Log 144 by 4. Then 144 by 4, is it possible to do division? If we need to do, that is 4 1s are 4 3s are 12, 4 6 are 24. So our final answer is log 36. Next question. Is log 2 a rational number or not? These kind of questions are most common in the section 1. Is log 2 a rational number? Is log 1000 a rational number? Is log 3 a rational number? Is log 5 a rational number? Is log 100 a rational number? Is log 10 a rational number? Like this kind of questions they will ask always. So how to solve these kind of questions? Just revise once back. That is how to change from logarithmic form to exponential form and exponential form to logarithmic form. That will be helpful here. Log 2. As I said already in the previous topic, for any logarithm, if the base is not given, means always the base will be 10. So here base is not given, right? Then I am writing the base as 10. Now, for this log 2, definitely some value will be there. So as now, we don't know that value. So that's why I am making it equals to some constant x. You can make it equal to y, a, b, c, d, anything, whatever you want. Now this is logarithmic form. This logarithmic form we need to convert to exponential form. Here the main number is 2 is equals to base is 10. So write it as it is as a base 10 power x. In the previous session only we discussed this one, how to convert from logarithm to exponential and exponential to logarithm. So 2 is equals to 10 power x. Now the thing is you need to do 10 power 1, how much? 10. 10 power 2, that is 100. 10 power 3, 1000. 10 power 4, 10,000, something like this it will go on. So, is there any number we can able to substitute in the place of x so that 10 power that number gives the answer exactly as 2? There is no such number. So, that is the reason this log 2 is an irrational number. There is no value for x which satisfies that equation. So that is the reason log 2 is an irrational number. Next, this is one of the very important questions. If x square plus y square equals to 25xy, then prove that 2 log of x plus y equals to 3 log 3 plus log x plus log y. First thing after looking at this question, what exactly we need to observe is any negative symbol is there in the question or not there. If negative symbol is not there at all, then add 2xy. For what we need to add, I will say. If negative symbol is there one time also, two times also, don't worry. If negative symbol is there in the question means you subtract 2xy. Just keep this in mind. If all positive symbols, then add 2xy. If at least one negative symbol is there, subtract 2xy. For what we need to add, what we need to subtract, now I am saying that one. This one. If x square plus y square equals to 25x is there, right? That one you take. X square plus y square is equals to 25x square, right? Now, if you observe this total question, everything is positive only. So, if everything is positive means what we need to do? Adding 2xy on both the sides. So, here plus 2xy. Here also plus 2xy. X square plus y square plus 2xy. X plus y whole square. 25xy plus 2xy. 27xy. Now, apply log both the sides. Then what it will become? Log of x plus y whole square equals to log 27xy. Here x plus y is the main number, so for main number power is there, then it will go to the front as it is. 2 log of x plus y is equals to log, here number 27 is there, right? 27 can be written as 3 power 3 xy as it is. If you observe this 3 power 3 xy, that is nothing but 3 power 3 into x into y. So 2 log of x plus y is equals to log 3 cube into x into y. Multiplication becomes plus 3 cube plus log x plus log y. Left side write as it is. 2 log of x plus y is equals to, this 3 will come to the front, then it will become 3 log 3 plus log x plus log y. Hence proved. This is what exactly we need to show. Now based on this one, you do this question. If x square plus y square equals to 6xy, then prove that 2 log of x plus y equals to log x plus log y plus 3 log 2. Write in roster form. Set a equals to x such that x is an integer and minus 3 less than or equals to x less than 7. So here he is asking to write a given set in the roster form. So roster form is nothing but we need to write all the possible elements from the given set. So set A is equals to x such that x is an integer and that x lies minus 3 less than or equals to x less than 7. So starting from minus 3, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. Here he is mentioning clearly that it is less than 7 only. So 7 we should not include. So this is the roster form of the given set. Write 3, 6, 9, 12 in set builder form. Now the previous question in reverse. In the previous question they gave set builder form and we wrote it in roster form. Now they only gave the roster form. Now we need to make it into set builder form. So set builder form is nothing but just we need to create some pattern or some logic between the given elements. Now observe this clearly. In the set builder form, this is compulsory, that is x such that x is equals to. X such that x is equals to. Now let us observe the elements clearly. 3, 6, 9, 12. This is a small trick only. 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12. So it is 3 table. So that can be written as 3 into some alphabet. 3n. Then n belongs to. We are writing here 3 1s are 1 starting onwards 1, right? So 1 is a natural number. So n belongs to natural numbers. And n less than 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12. So 12 So then n value will be less than 5. This is the set builder form of the given set. Now solving these two questions is your work. The first question I gave the roster form and you need to convert to set builder form. Second question I gave the set builder form and you need to convert to the roster form. Coming to the next one. Write subsets of the given set A, B, C. So writing the subsets is very easy. First write the individual elements one by one. So the first element is A, write it as the set, comma. Second element is B, write it as the separate set. Then third element is C, write it as the separate set. Then individual elements completed. Now go with the two elements together. A comma B, two elements as a set. Then B comma C, again two elements as the set separately. Then A comma C or else C comma A, anyway both are same. So one element separately completed, two elements separately completed. Now coming to three elements together. So three elements A comma B comma C. Now after writing all these, then we need to write one more element, that is empty set. So now these all are subsets of A comma B comma C set. Then related to this subset only, one more chance is there to ask one another question, that is write the power set. This word you remember just. If they ask only about subsets, write this answer as it is and finish it. In case if they ask to write the power set for all these subsets, you keep it in set, finish. It means power set is nothing but set of all the subsets. Then while writing the subsets also, sometimes we will get confused that instead of writing 8 elements, we will write 3 elements only, or 4 elements, or 7 elements, or 9 elements. Sometimes it happens. Then not to have this kind of confusion, just remember one formula also, that is two power n. Number of subsets formula. Number of subsets formula is 2 power n. N is nothing but how many elements are there in the given set, otherwise number of elements in the set. So now if you observe this set, here 3 elements are there. So 2 power n is nothing but 3 now. So 2 power 3, 2 into 2 into 2, 8. So for the given set ABC, if you write subsets, total 8 subsets should be there. Let us check whether we got all the 8 or not. 1, 2, 3, 4, 5, 6, 7 and 8. 8 subsets are there, of course. Then you write the subsets of 1 comma 2. It's very easy now. Next, coming to the operations of the sets: union, intersection and difference of the sets. If set A is equals to A comma B comma C and set B equals to A comma E comma I comma O, then find A union B, A intersection B, A minus B as well as B minus A. So first let us find out the value of A union B. So here A union B is equals to, set A is given as A comma B comma C, union set B is given as A comma E comma I comma O. Then union is nothing but all the elements from both the sets together we need to write. So now first let us write all the elements from the set A. So in the set A is there, then B is there, then C is there, comma. Now from the set B, if we start here, set B, first element is A, right? But already we wrote A, so don't repeat it again. Next, coming to the second element, that is E. E we didn't write, so write E here. Next element is I. I we didn't write, so I. Then O, we didn't write O also, so write it O here, finished. So this is A union B. We need to write each and every element from all the sets, but we should not repeat any element. Next, how to write then A intersection B? Let us check that. A intersection B is equals to, set A we have A comma B comma C, intersection Set B we have A comma E comma I comma O. So now intersection is nothing but from both the sets the elements which are common. We need to write only those elements. So here A and A. In both the sets only element A is common. So then A intersection B will be A. Finished. Next, the only problem with this, the next one, that is A minus B as well as B minus A. Of course, it's not a problem, but only small mistakes. Most of the students will repeat it in the exams. So set A is A comma B comma C minus set B is A comma E comma I comma O. Sorry, only O. Already habituated to write true vowels, so that's why I'm writing U also. Okay, now first thing what we need to do is remove all the elements which are common. That's it, finished. Now nothing is common, only element A is common, so I remove that elements. Now we are finding the value of A minus B, the first set A minus B. First set is A, right? So only pick the elements from set A. Now already A completed, then remaining is BC. So A minus B will be B comma C. Finished. Now don't touch the set B at all. Next, how to write B minus A, that in reverse. B minus A is equals to set B we have A comma E comma I comma O minus A comma B comma C. So set B minus set A now. Same as usual again, first remove all the elements which are common, here A and A. We are finding the value of B minus A, so first a set is set B. So only from the set B we need to write the elements still which are remaining. That is E, I, O. So B minus A will be E, I, O. Next, draw the Venn diagrams of A union B, A intersection B, A minus B, B minus A, and A is a subset of B. Let us check how to draw this. First I am drawing for A union B. Neatly draw one rectangular box. This rectangular box is nothing but universal set. Next, A and B, two sets are there, right? So make two circles inside of this rectangular box. One circle is for set A and one circle is for set B. Now he is asking here to find or to draw the Venn diagram or to represent the Venn diagram of A union B. So union is nothing but all together. Now these two circles we need to shade completely. This is the representation of A union B. Next, let us check A intersection B then. How to draw or how to represent A intersection B Venn diagram. Universal set. Take two circles. One circle for A and one circle for set B. Now we are drawing A intersection B. So here intersection is nothing but common. The elements which are common in both the sets. Now if we observe these two circles, in these two circles which part or which area or which region is common, that common part we need to shade. So this is the common part for both the circles. So just simply shade this part. So this is A intersection B. Then how to represent or how to draw A minus B then? Universal set as usual. One circle for set A and another circle for set B. Now this is for representation of A minus B. So A minus B. From set A, we need to remove completely set B. So don't touch the set B at all. Finished. That's it. Because from here onwards to complete set B, right? So that set B only I am not touching at all. So this is the representation of A minus B. Next, coming to B minus A. How to represent B minus A? As usual, AB. You can take BA also, it's up to you. Now B minus A, it means from the set B we need to remove. So from the set B, that's it. This is the shaded part, which is nothing but B minus A. Next, one more important Venn diagram, that is A. This symbol indicates subset. A subset B. It's very easy. Draw one smaller circle for A, bigger circle for B. So this is A is subset of B. A is subset of B. Now, if you observe all these Venn diagrams, these all Venn diagrams are especially for not disjoint sets. What is this disjoint set again? For any two elements, if single element is also not at all common, then those sets are called as disjoint sets. But whatever the Venn diagrams we discussed till now, those are not at all disjoints. It means at least one element will be common in those sets. That is the reason these all the circles are touching with each other. Observe this clearly. Here these two circles are touching with each other, so common element will be there. Here two sets are touching with each other, so common element will be there compulsory. Here also two circles or two sets are touching with each other, then some common will be there. Here also common. The same way A is subset B, this is also common will be there. Then what if no element is common? How to draw a figure for disjoint set then? It's very simple. The set doesn't have any common element, right? Simply write it separate, finished. Set A, set B. Cut. This much only. So disjoint, right? They don't have any common elements at all. Then how to represent A union B in this one then? Simply shade both. Then what about A intersection B? A intersection B, nothing will be there because no common element at all. Then in case if it is A minus B, means this much only you shade. Then what in case if it is B minus A, then shade this part. B minus A, completed. Just the thing is that those two sets or two circles should not be touching with each other because no common element. Next, if set A is equals to 1, 2, 3, 4 and set B is equals to 1, 3, 5, then verify n of A union B equals to n of A plus n of B minus n of A intersection B. So what is this n of? That's very easy. Set A is given as 1, 2, 3, 4. Then what is n of A? N of A is nothing but number of elements in the set A. Set A, if we observe this, here 1 element, 2 elements, 3 elements, 4 elements. So n of A is equals to 4. So in the set A, completely 4 elements are there. Then coming to the set B now. So set B is equals to 1, 3, 5. Now if we write n of B, number of elements in the set B. Here 1 element, 2 elements, 3 elements. So in the set B, total 3 elements are there. So now if you observe the question clearly again, n of A union B equals to n of A plus n of B minus n of A intersection B. In this, n of A value we got as 4 and n of B value also we got as 3. Then we need to find out n of A union B value as well as n of A intersection B value. So let us check how to find out this A union B as well as A intersection B, and from that how to get n of, number of elements. So first let us check what is A union B then. A union B, in the previous question only we discussed clearly how to find out union. Writing all the elements by removing the repeated elements. So set A we have 1, 2, 3, 4, 1, 2, 3, 4, in the set B we have 1, 3, 5, but 1 already we wrote, 3 already we wrote, so remaining is 5. Next, coming to the second set, that is A intersection B. So A intersection B is nothing but only the common elements. If we observe this set A and set B, number 1 is common as well as element 3 is also common. So A intersection B will become 1, 3. Now we need to find out n of A union B and n of A intersection B. So in A union B, we have 5 elements. So n of A union B will become 5. And in A intersection B, only 2 elements are there. So n of A intersection will be 2. Now let us substitute this total in the formula. The formula we have is n of A union B is equals to n of A plus n of B minus n of A intersection B. So what is the value of n of A union B? That is 5 is equals to n of A 4 plus n of B 3 minus n of A intersection B 2. So 5 is equals to 4 plus 3 7, 7 minus 2 5. So 5 is equals to 5. Next, coming to the polynomials. In this, the first kind of topic we would like to discuss, or one of the very important things, especially which covers in part B, is they will give some expressions and they will ask us to find whether those are polynomials or not. So how to check what exactly the difference is there between polynomial as well as an expression? A small difference will be there. For any expression, if the power of a variable is whole number, then that expression will become polynomial. For any expression, the power of a variable is whole number, then that expression is considered as polynomial. Otherwise, it is not a polynomial. So in simple words, if we say in the given expression, check the alphabet only. For that alphabet, if the power is a whole number, then it is polynomial. Otherwise, not a polynomial. So let us check one by one now. First is given as x square plus 5x plus 6. Here x power is 2. 2 is a whole number. Okay. Next, here one more x is there. For x power is not there, it means 1. 1 is a whole number. Yes, that's it. All alphabets completed in the first question now. X square plus 5x plus 6. X power 2 is a whole number. X power 1, it is also a whole number. So both are whole numbers. Then this is polynomial. Next, second one. 2x power 4 plus 5x square. Here x power 4 is there, 4 is a whole number. X power 2 is there, 2 is also a whole number. Both the powers are having whole numbers, so this is also a polynomial. Then next question, 2022. Then 2022 in this alphabet only, not there at all. Then is this a polynomial or not? Of course, it is also a polynomial, because 2022 can be written as 2022 into 1. 2022 ones are 2022 only, no value, nothing changed. Then this 2022 into 1, I am replacing with x power 0. In the chapter exponents and powers, we will be having one formula, a power 0 equals to 1. In simple, any number power 0 is equals to 1. So 1 I am replacing with x power 0. Now if we observe the power for this x, that is 0. 0 is a whole number. So this is also a polynomial. It means every constant is a polynomial only. Coming to the next one. 4x power minus 4. Here power is minus 4. Minus 4 is not a whole number. So this is not a polynomial. Next one. X power 2. It is a whole number only. Power minus 3. Minus 3 is not a whole number. So this is not a polynomial. Next. 1 by x plus 2. Here we need to do a little simplification for this one. 1 by x. 1 by x means x power minus 1 plus 2 as it is. Now power is minus 1. Minus 1 is not a whole number. So this is not a polynomial. Next question. Root x plus 5x square. Root x, what is the value of root x? X power 1 by 2 plus 5x square. Now Here power 1 by 2, power 1 by 2, 1 by 2 is not a whole number, so this is not a polynomial. Next, x power 2, 2 is a whole number. Here for x no power is there, so it means 1 is the power. Then x power 1 is there, 1 is a whole number, so power 2 is a whole number, power 1 is also a whole number, so then this will become a polynomial. Just simply observe the difference between these two questions now. In this question, root is for alphabet, whereas in this question, root is for a number. So if a root, any root, square root, cube root, whatever it may be, if that root is there means for alphabet, then it is not a polynomial. In case if the same square root is there for number, then it is a polynomial, no problem at all. Next one, finding degree of the polynomial. It's very easy. First, in the given polynomial, check all the powers of the variables. For x, power is 4. For x, power is 2. This is constant, right? For constant, what is the power? Just lastly we discussed here. 2022. Constant. What is the power here? 0. For any constant, the alphabet power is 0. So 4, 2, 0. Now, we wrote the individual powers of the variables. Then from these numbers, which is the biggest number? Obviously 4 is the biggest, then 4 is the degree of the total polynomial. Let us check second one. X power 5, here 5 is the power. Here for x nothing is there means 1, so 1 is the power. 6, that is constant, so 0 is the power. 5, 1, 0. In 5, 1 and 0, the biggest number is 5. So 5 will be the degree of it. Now if you observe these two clearly, in these two, one alphabet only there, not two alphabets at all. Now coming to the third one, x, y, x into y is there. So whenever if multiplication is there in between two alphabets, we need to add the powers. For x no power, so 1. For y no power, 1. 1 plus 1, 2, comma. Here x power is not there means 1, comma. Here 5, that is a constant, so 0. 2, comma, 1, comma, 0. From these three, 2 is the biggest. So 2 is the degree of the given polynomial. Then 2022. As usual, just like the previous one, 2022 can be written as 2022 ones. 2022 into 1 can be replaced with any number power 0. So I am replacing with x power 0. Now here for x, the power is 0. Then the degree will be 0. So 2022 is a constant. For constant, the degree is 0. Then what is the degree of the number 0 itself then? Let us check once. 0 can be written as 0 into 1. 0 can also be written as 0 into x. 0 can also be written as 0 into xy. 0 can also be written as 0 into x power 1000. 0 can also be written as 0 into x power 1 lakh, 1 crore to x power whatever it may be. Because 0 into anything is 0 only. Now if we observe the individual powers. Here number 1 is there, so 1 is a constant, so power will be 0. Here x nothing power is there means 1, so power is 1. Here x power 1, y power 1 plus 1, 2. Here x power 1000. Now, not only these 4 cases, like this, infinite cases are possible. So, if we check those infinite cases, for all the possibilities, different will be the degree. So, that is the reason for number 0, degree is not defined. Just keep these two numbers clearly in your mind. 2022, that is constant. For any constant, degree is 0. Next, what is the degree of 0 itself then? Degree of 0 is not defined. Next, what is the coefficient of x cube? Not only x cube, they may ask x square or x, whatever it may be they are asking. The concept is the same every time. So in this question, he is asking coefficient of x cube. So coefficient of x cube is nothing but before the x cube, which number will be there, that is the coefficient. So let us check one by one now. Here x cube term is there, right? Before x cube, what number is there? That is 2. So 2 is the coefficient of x cube. Next, second one. Here this is x cube. So before x cube, what is there? Minus 3. Don't forget the negative symbol ever. Minus 3 is the coefficient of x cube. Next, coming to the last one, that is x square plus 5x plus 6. If you observe this clearly, in this polynomial, first of all, x cube term only not there. If that term is completely missing, then write the coefficient as 0. Next, value of x cube minus 2x square minus 5x plus 6 if x equals to minus 1, 1, 2, minus 2 and 1 by 2. So finding the value of a polynomial for the given x value. So let us check one by one now. The polynomial is given as x cube minus 2x square minus 5x plus 6. And the values are, x value is given as minus 1. So first let us go with the minus 1. Then after one by one number we will go with. So simply wherever we have x in the polynomial, we need to substitute that x value with a minus 1. So here x is there. Just simply write minus 1. Power 3 as usual. Minus 2 as usual. Again here x is there. So in the place of x, keep minus 1. Power 2 as usual. Minus 5 as usual. Again here x is there. So in the place of x, minus 1. Next, plus 6. Now we need to simplify all this. Let us simplify this. Minus 1 power 3. Minus 1 power 3 is nothing but minus 1 we need to multiply 3 times. So minus 1 into minus 1 into minus 1. That is minus 1. Minus 2 into, here we have minus 1 whole square. Minus 1 whole square is nothing but minus 1 into minus 1. Minus 1 into minus 1 plus 1. Then minus 5 into minus 1 plus 6. So now if we still simplify this further, let us check what we'll get. Minus 1, minus 2 into 1, minus 2, minus 5 into minus 1, minus into minus, plus 5, plus 6 as usual. Now 6 plus 5, 11, 11 minus 2, 9, 9 minus 1, 8. So the value of the given polynomial when x is equals to minus 1 is 8. Next, the same polynomial he is asking to find if x is equals to 1. So the polynomial is x cube minus 2x square minus 5x plus 6. Now he is asking to substitute x is equals to 1. So simply in the place of x in the given polynomial, we need to substitute 1 now. So 1 power 3 minus 2 into 1 power 2 minus 5 into 1 plus 6. 1 power 3, that is 1 into 1 into 1, 1 minus 2 into 1 square, 1 into 1, 1 minus 5 into 1 plus 6, 1 minus 2 ones are 2 minus 5 ones are 5 plus 6, 6 minus 5, 1, 1 minus 2 minus 1, minus 1 plus 1, 0. So the value of the polynomial when x is equals to 1 is 0. Then your task is find the value of the polynomial if x is equals to 2 and x is equals to minus 2. Now I will explain for 1 by 2. So the given polynomial is x cube minus 2x square minus 5x plus 6. plus 6. Then he is asking the value of this polynomial when x is equals to 1 by 2. So simply in the place of x, let us substitute 1 by 2. 1 by 2 whole power 3 minus 2 into 1 by 2 whole square minus 5 into 1 by 2 plus 6. What exactly this 1 by 2 whole cube means? This whole cube is applicable for numerator as well as for denominator. That can be written as 1 cube by 2 cube minus 2 into this square is applicable for numerator as well as for denominator. 1 square by 2 square minus 5 into 1 by 2 plus 6 as it is. Now coming to the simplification of this. 1 cube 1 by 2 cube. Here if you are not perfect in the calculations, please don't do mistakes. 2 cube, don't write it as 6. 2 cube is nothing but 2 into 2 into 2. So 2 2s are 4, 4 2s are 8. Minus 2 into 1 square 1 by 2 square, 2 2s are 4. Minus 5 times 1 by 2 plus 6. 1 by 8 minus 2 1s are 2 by 4 as usual minus 5 1s are 5 by 2 as it is plus last term is 6, right? That 6 I am writing it as 6 by 1. Now if you observe this clearly, here all the denominators are different, so we need to do LCM of those numbers. LCM of 8, 4, 2 and 1 is 8. In 8 table where we will get 8 1s are, so multiply with 1. In 4 table where we will get 8 2s are, so multiply with 2. In 2 table where we will get 8 4s are, so multiply with 4. In 1 table where we will get 8 8s are, so multiply with 8. So now if you multiply these all, 1 1s are 1, minus 2 2s are 4, minus 5 4s are 20, plus 8 6 are 48. So let us do this simplification now. 48 minus 20, 28. 28 minus 4, 24. 24 plus 1, 25. So the value is 25 divided by 8. The next type is, what is the remainder? What is the remainder when x plus 1 is divided by x cube plus 5x plus 6? Next, the second question. Based on the same concept only, second question. Check whether x plus 1 is a factor of x cube plus 5x plus 6 or not. Next, same concept, another question. Check whether x plus 1 is a divisor of x cube plus 5x plus 6 or not. Same question, same concept. The next question is, check whether x cube plus 5x plus 6 is a multiple of x plus 1 or not. So in the question, factor, divisor, remainder, multiple, whatever it may be, these all words, you need to do the same process. Let us check once. Here the number or divisor is x plus 1. X plus 1 is given. So you need to substitute minus 1 in the place of x. That is the only thing, just remember clearly. In case x minus 1 is given, means you substitute plus 1. For example, x plus 4 is given. So plus 4 is given, right? You need to substitute minus 4. Otherwise, x minus 3 is given. So minus 3 is given, right? You need to take plus 3. So now here x plus 1 is given, right? So simply you need to substitute minus 1. Here x is there, so minus 1 power 3 plus 5 into, here x is there, minus 1 plus 6. Minus 1 power 3 minus 1 plus 5 into minus 1 plus 6. If you do simplification of this, minus 1 plus into minus, 5 1s are 5 plus 6. Now if you observe this further still, minus 1 6 minus 5 1, 1 minus 1 0. So answer is 0. Now after simplifying like this, check what is the final answer. If you get answer 0, then x plus 1 is a factor, x plus 1 is a divisor. This is x cube plus 5x plus 6 is the multiple of x plus 1. In case if it is not equals to 0, then that is not a factor, that is not a divisor, that is not a multiple. Finished. Just same like how we are finding the value of the polynomial, the same, but the only thing is that we need to change whether the given pair of linear equations in two variables are consistent or not consistent. So before going to this one, we need to have a clear idea what exactly this consistent or not consistent means. Whenever we are drawing two straight lines, there are three possible cases. These are the three possible cases. The two lines may touch with each other at only one point. The two lines may not touch at all, parallel lines. The two lines may be overlapping one on another. So in this first case, these two lines are touching with each other, so it will be having one solution. In the second case, the two lines are not at all touching, those are parallel lines, so 0 solution. In the third case, the two lines are sleeping one on another, so overlapping, so then those lines are called as coincident lines. So in these coincident lines, we will be having infinite solutions. If the two pair of linear equations in two variables will be having at least one solution, then they are called as consistent. If at least solution only not there, means that those are inconsistent. So in simple, parallel lines are inconsistent. Just remember that one. Parallel lines are inconsistent. Finished. Then remaining both comes under consistent. Then how to check whether those lines are touching with each other, or else they are overlapping with each other, or else they are not at all touching with each other? For that only we will go with the ratios. The formula is A1 by A2. We need to find out. So what exactly is A1 and A2? In the first equation, x coefficient is 5. That is A1. So 5 divided by, in the second equation, x coefficient is 2. That is A2. So 5 by 2. A1 by A2 ratio we got. Next, we need to compare B1 by B2 ratio. So B1 by B2 ratio. What exactly is B1 and B2? In the first equation, y coefficient, that is plus 3 or simply 3, divided by, what is B2 then? In the second equation, y coefficient, that is minus 4. So now these two values we need to compare first of all. Oh sorry, I thought to change the marker color, then again I wrote with the same one. Okay, minus 4. Then C1 by C2, that is constants, C1 by C2. In the first equation, the constant is 5, so 5 divided by, in the second equation the constant is 4, so 4, 5 by 4. Now first compare A1 by A2 value and B1 by B2 value. So here A1 by A2 is 5 by 2 and B1 by B2 is 3 by minus 4. Easily we can say that both are not at all same. So A1 by A2 is not equals to B1 by B2. Whenever A1 by A2 and B1 by B2 are not at all equal, then no need to compare the next one, C1 by C2. So if A1 by A2 is not equals to B1 by B2, then those are intersecting lines. So intersecting lines is nothing but they are touching with each other at one point, right? So one point they are touching means at least one solution will be there. So if one solution is there, means then they are called as, or considered as, consistent pair. Next, 3x plus 5y equals to 7, 6x plus 10y equals to 14. Again same here also, we need to first check A1 by A2 value. Here A1 is 3 and A2 is 6. So 3 divided by 6, nothing but 1 by 2. The same way b1 by b2. b1 by b2. Here b1 is 5 divided by b2 is 10. 5 by 10 as usual 1 by 2. Then comparing c1 by c2. c1 by c2 constant, that is 7 and 14. 7 by 14 is equals to 1 by 2. Now if we observe all these ratios, that is 1 by 2, 1 by 2, 1 by 2. So we can say one thing clearly here, that is a1 by a2 is exactly equals to b1 by b2 is also equals to c1 by c2. If all the values are equal to each other, then those lines are coincident lines. Coincident. If they are coincident means definitely one line is sleeping on another, or else both are overlapping. It means infinite solutions. So infinite solutions are there means definitely one solution will be there. So definitely one solution will be there means these are consistent pair. Next, the same questions in reverse now. If 3x plus 2y equals to 4 and 6x plus py equals to 8 has infinite solution, then find the p value. So what is the condition for having infinite solutions? a1 by a2 is equals to b1 by b2 is equals to c1 by c2. So first of all, what is a1 here? That is 3 by a2 6. That should be equals to b1 2 by b2 p. That also equals to c1 4 by c2 8. So 3 by 6 is equals to 2 by p is equals to 4 by 8. Now take any two. These two I am taking and I will make it equals to each other. 3 by 6 is equals to 2 divided by p. Let us do cross multiplication. 3 into p, 3p is equals to 6 into 2, 12. We need to find out the p value, so take 3 to the right side. So p is equals to 12 divided by 3. 3 ones are 3 fours are, then p value is 4. So in this given equation, in the place of p, if we substitute 4, then these two equations will be having infinite solutions, coincident lines. Next, this is one of the very important elimination method. We need to use elimination method to find the values of x as well as y. So what exactly we need to do in this is, first equation you multiply with second equation x coefficient. This is the second equation, right? So second equation x coefficient is 2. So multiply with 2. Next, second equation you multiply with first equation x coefficient, that is 3. That's it. Now let us do multiplication of these two. 3x into 2, 6x, minus 4y into 2, 8y, is equals to minus 6 into 2, minus 12. The same we need to do with the second equation also. 2x into 3, 6x, plus 4y into 3, 12y, is equals to 16 into 3, 16 3 is a 48. Now these two equations we need to do simplification. So before going to the simplification, just observe the symbols. Here 6x is plus, here 6x is plus. If both both the coefficients are having same symbol, that is plus plus or else minus minus. If both equations are having the same symbol, then do subtraction. Just keep this in mind. If both are same symbol, then do subtraction. So this plus becomes minus, plus becomes minus, plus becomes minus. 6x, 6x cancel. Minus 8y, minus 12y, minus 20y, minus 12, minus 48, minus 60, minus minus cancel. Then we remains with 20y is equals to 60. Take 20 to the right side. So y is equals to 60 divided by 20. 21s are 23s are. So y value is 3. Now this y value we need to take and we need to substitute either in the first equation or else in the second equation or else in this third one or else in this fourth one. Anything you take. First one I'm looking, second one is looking like little easy. I'm taking the second one, that is 2x plus 4y equals to 16. 2x plus 4y is equals to 16. 2x plus 4 into y value we got as 3 is equals to 16. 2x plus 4 3s are 12 is equals to 16. Take plus 12 to the right side, then it becomes minus 12. So 2x is equals to 16 minus 12. 2x is equals to 16 minus 12 is 4. Then x is equals to 4 by 2. 2 1s are 2 2s are. So x value is 2. So for the given two equations, x value is 2 and y value is 3. Let us check one more. What is the x and y values if 3x plus 2y is equals to 7 and 4x minus 3y equals to minus 2? First equation we need to multiply with the second equation x coefficient, that is 4. Second equation we need to multiply with the first equation x coefficient, that is 3. Is this the only process to do? Means no, obviously many methods will be there, but I felt always this is the easy so that no one will be having any confusion. That's why I will stick to this method only every time. 3x into 4 12x plus 2y into 4 8y is equals to 7 into 4 28. Now multiply same with the second equation also. 4x into 3 12x minus 3y into 3 minus 9y is equals to minus 2 into 3 minus 6. Now the first thing we need to do is checking for the symbols. Here it is plus 12x, here it is also plus 12x. So both the symbols are same. If both the symbols are same, then we need to do subtraction. So here plus becomes minus, minus becomes plus, minus becomes plus. So plus 12x minus 12x cancel. 8y plus 9y, 17y is equals to 28 plus 6, 34. So 17 if we take to the right side, then y is equals to 34 divided by 17. 17 ones are 17 twos are. Y is equals to 2. Now this y value we can substitute in either in this first equation or else second equation or else third equation or else fourth equation. First equation I am taking, that is 3x plus 2y equals to 7. 3x plus 2y equals to 7. So 3x plus 2 into y value we got as 2 is equals to 7. 3x plus 2 2s are 4 is equals to 7. Take plus 4 to the right side, then it becomes minus 4. 3x is equals to 7 minus 4. Then 3x is equals to 7 minus 4 is 3. X is equals to 3 divided by 3, that is 1. So x value is 1 and y value is 2. Now till now the method which we did is elimination method. Now we will go and we will discuss with a substitution method. Either you go with the elimination method also or else a substitution method also. Always you will get the same answer only. In the exam, if they mention particular method for any question, not only this chapter, not only these methods, not only this topic, for any topic, for any chapter, if they mention any particular method name, then compulsory you need to do with that method only. In case if they didn't mention any method name, it's up to you. Whatever you feel it as easy, you go with that method only. So now let us discuss this substitution method then. Same first question only I took because let us also compare whether we got the same answer or not. Of course same answer only we'll get, but just clarity. Either the first equation or else second equation, any one you take, it's up to you. I'm taking the first equation, that is 3x minus 4y is equals to minus 6. From this, find out the x value or else y value. This is also your wish only. So I'm willing to find out the x value from this. So I will take this minus 4y to the right side. 3x is equals to minus 6. Minus 4y if we take to the right side, then it will become plus 4y. I want x value, right? So I need to take this 3 also this side. 3 here it is multiplication. If I take another side, it becomes division. Then x is equals to minus 6 plus 4y divided by 3. This is the x value. This x value I found from the first equation. Then this x value you need to substitute only in the second equation. This is the only problem with this substitution method. Always keep this in mind. First equation we took for solving the x value or else for y value. Then after getting that particular x value or y value, we should not substitute in the first equation again. We should compulsory substitute in the another equation only. In case if you took the second equation, substitute in the first equation. Okay, so second equation is 2x plus 4y equals to 16. 2x plus 4y is equals to 16. Now here in the place of x, this number we need to substitute. 2 into x is minus 6 plus 4y divided by 3 plus 4y is equals to 16. 2 into minus 6 minus 12 plus 2 into 4y 8y divided by 3 plus 4y equals to 16. Here 4y I am writing it as 4 by 4y by 1. Now both the denominators are different, so let us go with the LCM method or else cross multiplication method, whatever you feel it as easy. 3 ones are 3, then cross multiply. Minus 12 plus 8y into 1. 1 if you multiply means nothing will change. Minus 12 plus 8y as it is plus 3 into 4y. 3 4s are 12. 12y is equals to 16. Now if you simplify this, minus 12 as it is, then 12y plus 8y 20. 20y by 3 is equals to 16. Take this 3 to the right side. If you take another side, it becomes a multiplication. Minus 12 plus 20y is equals to 3 into 16. 16 3s are 48. Now take minus 12 also to the right side. Minus 12 if you take another side, it becomes a plus 12. 20y is equals to 48 plus 12. So we will get 20y is equals to 48 plus 12, 60. Then y is equals to 60 divided by 20. 21s are 23s are. Then y value is equals to 3. Now this y value you can substitute either in the first equation or else in the second equation, so that you will get x value. This y value you substitute in any one of the equation, either first equation or else second equation. But in the beginning, whatever the equation you are taking, after getting the value, you need to substitute definitely in the second equation only or else another equation only. But after getting one value like this completely, now here we got a y value, right? So after getting this y value, you can substitute in any one of the equations, you will get the x value, no doubt at all. Is x plus 1 whole square plus 3 equals to 2x plus 4 whole square a quadratic equation? So first of all, what is a quadratic equation? For any equation, if the degree is 2, then that equation is considered as quadratic equation. So first let us simplify this equation. Then after we will confirm what is the degree of that. X plus 1 whole square plus 3 is equals to 2x plus 4 whole square. This is the given equation. First here, if you observe this left side part, x plus 1 whole square. X plus 1 whole square is in the form of a plus b whole square. So if we expand it, x square plus 1 square plus 2 into x into 1. Nothing but a square plus b square plus 2ab formula. Plus 3 as usual is equals to, same right side also we have one more 2x plus 4 whole square. That is a plus b whole square formula again. So if we expand that, a square plus b square plus 2 into a into b. So now let us simplify this further. X square as it is plus 1 square is 1 plus 2 into x into 1, 2x plus 3 as it is equals to 2x whole square, 4x square plus 4 square 16 plus 2 2s are 4, 4 4s are 16, 16x. Now for simplifying further, I am taking everything to the left side. So x square plus 1 plus 2x plus 3 plus 4x square if I take to the left side becomes minus 4x square plus 16 if I take to the left side becomes minus 16 plus 16x if I take left side it will become minus 16x is equals to 0. Now let us do addition or subtraction of the like terms. X square minus 4x square minus 3x square, 2x minus 16x minus 14x, 1 plus 3 4, 4 minus 16 minus 12 is equals to 0. Now this is the final equation after simplification. If we observe this clearly now, 3x square is there, sorry, minus 3x square is there, power is 2. So if the power is 2 or else a degree of the equation is 2 means then it is considered as quadratic equation. Next one, factorization of the quadratic equation, sorry, equals to 0 equals to 0 equals to 0 equals to 0. Okay, factorization of the quadratic equation or else finding zeros or roots of quadratic equation or else splitting the middle term into two terms. So in this I am going to explain with 4 types of questions. The first question, all terms are positive. Second question, only the middle term is negative. Third question, second term and third term both are negatives. Fourth type, last term only is negative. Then how to solve these kind of questions? Let us check one by one. First we will go with x square plus 5x plus 6 equals to 0. X square plus 5x plus 6 is equals to 0. So what we need to do for this solving is constant you need to multiply with x square coefficient. Here before x square nothing is there, so it means 1. 6 we need to multiply with 1, that is 6. Now 6 will come in which tables? Check all those things. 6 will come in 1 table, 1 6 are. 6 will come in 2 table, 2 3s are. Then 3 2s are, 6 1s are. So only 2 possibilities are there. Now observe the symbols. In this total equation, all the symbols are positives only. If every symbol is plus means in these numbers write everything plus. So plus 1 plus 6 is plus 7, plus 2 plus 3 is plus 5. Here the middle number is plus 5. Here we got this as plus 5. So this pair is the correct pair. So in the place of middle term or else middle term we need to replace this one. First term x square as it is plus this 5x I am replacing with this one, that is 2x plus 3x plus 6 as it is equals to 0. Now we need to take something common from the first and second terms. From the first and second terms x square plus 2x we can able to take x common. So then we remains with x plus 2. Now from the third and fourth terms also we need to take something common. After taking the common, here what we got in the bracket, the same we need to get here also. Just keep that in mind. Now observe the third term, that is plus 3x, right? Here already x completed, the remaining is plus 3. So plus 3 we need to take common. Now here x plus 2 is there, here x plus 2 is there. Write it one time, x plus 2 times here x, here plus 3, x plus 3 equals to 0. Now x plus 2 make it equals to 0, x plus 3 also make it equals to 0. So x plus 2 if it make it equals to 0, plus 2 if we take another side it becomes minus 2. So x value is minus 2. The same way x plus 3 also. X plus 3 if it make it equals to 0, plus 3 take another side then it will become minus 3. So x is equals to minus 3. So the zeros or roots of the given quadratic equation are minus 2 and minus 3. Let us check the second question in this. X square minus 5x plus 6. X square minus 5x plus 6 is equals to 0. The first thing is as usual multiplying the constant and x square coefficient. Here constant is 6. We need to multiply with x square coefficient. Here before x square nothing is there means 1. So 6 1s are 6. Right where the 6th table will come. So 6 table will come in 1 6 and 2 3s. 3 2s are 6 1s. So only 2 pairs are possible. Now observe the given equation. If the only middle term is negative, then here every number should be negative. Now minus 1 minus 6 is minus 7, minus 2 minus 3 is minus 5. Now if we observe the middle term here, that is minus 5. So this second pair is correct for us. So write the first term as it is x square. Now this minus 5x we need to replace with this one, minus 2x minus 3x plus 6 as it is equals to 0. From the first and second terms we can take out x common, then we remains with x minus 2. Now from the third and fourth terms also we need to take something common. After taking common, here what we got in the bracket, the same we need to get here also, that is x minus 2 equals to 0 as it is. Now observe the third term clearly, that is minus 3x. Here already x completed, the remaining is minus 3. Now x minus 2 2 times is there, write it once, x minus 2 times x minus 3 equals to 0. Now here two factors are there, right? That is x minus 2 and x minus 3. Make them equal to 0. X minus 2 equals to 0. Minus 2 if you take another side, plus 2. So x is equals to 2. The same way second factor, x minus 3, make it equals to 0. Minus 3 if you take another side, it will become plus 3. So x is equals to plus 3. So plus 2 and plus 3 are the factors, zeros of the given quadratic equation. The same way, let us check the third one then. X square minus x minus 6. X square minus x minus 6 is equals to 0. The first thing is as usual, constant is 6 multiplying with the x square coefficient, that is 6 1 the 6, it will come in 1 6 and 2 3. Now coming to the symbol. If the middle one and last term both are negatives, means in these pairs the bigger number should be negative and the smaller number should be positive. 1 6, bigger number is 6, so 6 should be negative. Plus 1 will be plus. 2 and 3 is the bigger number, right? So it should be negative and 2 should be positive. Plus 1 minus 6 minus 5, plus 2 minus 3 minus 1. Here the middle term is minus x, so before x nothing is there, means minus 1x. So this second pair is correct for us. Now write the first term as it is x square. Minus 1x can be replaced with plus 2x minus 3x. Minus 6 is equals to 0. From the first and second terms we can take out x common, then we remains with x plus 2. Now from the third and fourth terms also we need to take something common, then after taking that common we need to remains with x plus 2 only as it is. Now if we observe the third term, that is minus 3x, here already x completed, then we remains with minus 3 equals to 0. Now x plus 2 is 2 times, right? So write it one time, x plus 2 into remaining is x minus 3 is equals to 0. Now make x plus 2 is equals to 0 as well as x minus 3 is equals to 0. So x plus 2 equals to 0. Plus 2 if we take another side becomes minus 2. So x is equals to minus 2. X minus 3 is equals to 0. Take minus 3 another side becomes plus 3. So x is equals to plus 3. Minus 2 and plus 3 are the roots or zeros of the given quadratic equation. Now coming to the last question. This last question, you do it. Here only the last term is negative. So if only the last term is negative, means from the given pair or else whatever the pair we will get, from that pair bigger number should be positive and smaller number should be negative. That's it. You try this one. Next, finding the nature of the roots or else finding discriminant of a quadratic equation. So for these both the processes, or else finding the nature of roots or finding the discriminant of a given quadratic equation, the process is same. So let us check once. So whenever if they ask to find out the nature of roots or else to find out the discriminant, you need to use this formula, that is b square minus 4ac. What exactly this a, b, c values from the given quadratic equation means? X square coefficient, that is a. So here a value is 1. X coefficient is b. So b value is minus 3. As usual, c is for constant. So constant is c. Then let us substitute in this now. B square minus 3 square minus 4 into a value 1 into c value 5 minus 3 square 9 minus 4 1s are 4 4 5s are 20 9 minus 20 minus 11. So until here if you are solving, this is considered as discriminant. Completed. Then if they ask nature of the root, just one more line extra we need to do. That is comparing this value with that is b square minus 4ac value, we need to compare with 0. Whether that value is less than 0 or else exactly equals to 0 or else greater than 0. If b square minus 4ac value is less than 0, then the roots are imaginary roots. If the b square minus 4ac value is exactly equals to 0, then the roots are real and equal roots. If b square minus 4ac value is greater than 0, then the roots are real and distinct. Distinct is nothing but different. So if we observe here now, b square minus 4ac value we got as minus 11. So minus 11 is nothing but smaller than 0. So smaller than 0 means imaginary. So for the given quadratic equation, the roots are imaginary. Next one. If x square minus px plus 9 has equal roots, then find p value. So what is the condition for having equal roots? This one. b square minus 4ac value should be exactly equals to 0. b square minus 4ac should be equals to 0. Now observe what are the ABC values from the given quadratic equation. X square coefficient 1. So a value 1. X coefficient is minus p. So b value is minus p and constant is 9. So now these all we need to substitute in our formula, that is b square minus 4ac equals to 0. So b square minus p square minus 4 into a value 1 into c value 9 equals to 0. Minus p square minus 4 1s are 4, 4 9s are 36 is equals to 0. Take this minus 36 to the right side, then it becomes plus 36. So p square is equals to 36. Then what will be the p value? Plus or minus 6. So p value is plus or minus 6. Next, coming to the progressions. Is 2, 4, 6, 8 an AP arithmetic progression. So whenever if they are asking about arithmetic progression, we need to check the common difference. This is first term called as A or else A1. This is second term A2. This is third term A3. This is fourth term A4 and continues like that. So now we need to find out the common difference. D, common difference is represented with D. So common difference D is equals to second term minus first term, that is A2 minus A1, and difference is equals to third term A3 minus second term A2. So it's very simple. These two numbers difference you need to find out. Then these two numbers difference you need to find out. And you need to compare whether both are equal or different to each other. Let us check once. Here, what is A2? 4. Minus A1, 2. 4 minus 2, it is 2. Then A3, 6. Minus A2, 4. 6 minus 4, 2. Here, the difference in both the cases is same. So, as the common difference is same, then it is an AP. Arithmetic progression. Next, write A comma D in the given arithmetic progression. So A is nothing but first term and D is nothing but common difference. So from the given progression, just we need to given arithmetic progression, we need to write the first term and common difference. So whatever is the first number, that is only first term. So A or else A1 is equals to 2. Then finding the common difference. Common difference is A2 minus A1, that is 7 minus 2. 7 minus 2 is equals to 5. So the common difference is 5 and first term is 2. Next, find 25th term of the given arithmetic progression. To find any term in the given arithmetic progression, we have one formula, that is nth term formula or general term formula. The formula is an equals to a plus n minus 1 into d. This is the nth term formula or general term formula. This formula we will use to find out any number of the term. Maybe 10th term or 20th term or 100th term or 55th term, 56th term, whatever it may be. So now, before going to the solving this, let us check what are the values in the formula. Here A is there, A is first term or else A1 simply. N, which number of term they are asking. So in this question they are asking 25th term. So N value will become 25. Then D, common difference, right? That is second term minus first term. A2 minus A1. Let us check all this then. So what is the A value from the question? First term, that is 4. So A value 4. Next, N value 25 because they are asking to find out the 25th term. And what about the common difference then? That is second term minus first term. So here the second term is minus 1 minus first term is 4. Minus 1 minus 4, that is minus 5. So every value we have. Now let us substitute these all in the formula. A 4 plus N 25 minus 1 into D minus 5. So let us simplify this. 4 plus 25 minus 1, 24 into minus 5. 4 plus into minus minus. 24 5s are 5 4 is 20, 0 2, 5 2 is 10, 12, 120. So 4 minus 120 minus 100 and sorry not 60, 16 minus 116. So in the given arithmetic progression, if you write that progression continues like that only, then the 25th term will be equals to minus 116. Let us check one more question. Find 10th term of the AP. So we have the formula, that is AN equals to A plus N minus 1 into D. So now from this given arithmetic progression, what is the A value? That is first term 12. N value, they are asking the 10th term, so 10. Then what will be the common difference? Second term minus first term, right? So let us do that one. Second term is 10 minus first term is 12. 10 minus 12 minus 2. Let us substitute these all in the formula now. So A value 12 plus N value 10 minus 1 into D value minus 2. That is 12 plus 10 minus 1, 9 into minus 2. 12 plus into minus minus, 9 to 18. 12 minus 18 minus 6. So for the given arithmetic progression, the 10th term is minus 6. Next, is 201 a term of the arithmetic progression 3, 7, 11, 15 and so on. So here we have an arithmetic progression 3, 7, 11, 15 and so on. If we write all the terms in this, the like 3, 7, 11, 15, next term will be 19, then 23, then 27, like that if we continue, is there any chance that we will get 201 in that arithmetic progression or not? So for this kind of question also, the same formula, that is nth term formula. An equals to A plus N minus 1 into D. So 201 he is asking, so that will become An value 201 is equals to A value first term, that is 3, plus N value. In the previous questions they gave N value, but in this one N value we need to find out. So N is an unknown number, write N as it is, minus 1 into D, common difference, that is second term minus first term. Here second term is 7, first term is 3. 7 minus 3, 4. So let us simplify this now. This 3 I am taking to the left side, then we become minus, right? So 201 minus 3 is equals to N minus 1 times 4. 201 minus 3, 198 is equals to N minus 1 into 4. Now this 4 if we take to the left side, here it is multiplication, then if we take another side it becomes division. 198 divided by 4 is equals to N minus 1. So here 198 by 4, if we do division, we won't get a natural number. Instead of that, we will get some decimal. That is 49.5 is equals to N minus 1. Minus 1, if we take another side, it becomes a plus 1. Then N is equals to 49 half plus 1, that is 50 half. Now let us observe the question clearly once. first term, second term, third term, fourth term, fifth term, 10th term, 201 term, 200 term, and 1000th term. Everywhere we are saying the number of terms in terms of natural numbers only, but we are not saying that 3.3 term, 2 by 3 term, 1 by 4 term, like that we are not saying. So always the number of terms will be a natural number only. But here if you observe the n value is some decimal, so n value is not a natural number, then so 201 is not a term in the given arithmetic progression. N does not belongs to natural numbers, so that is the reason 201 is not a term in the given arithmetic progression. Next, the same kind of question. Is minus 25 a term of the given arithmetic progression? Same formula. An equals to a plus n minus 1 into d. So he is speaking about minus 25, right? So an value will be minus 25 is equals to a value first term 4 plus n value we need to find out. Common difference, that is second term minus first term. Here second term is 2 and first term is 4. 2 minus 4 minus 2. Now take this 4 to the left side. So 4 if you take another side becomes minus 4. Minus 25 minus 4 is equals to n minus 1 into minus 2. Minus 25 minus 4 minus 29 is equals to n minus 1 into minus 2. Take minus to this side. So minus 29 divided by minus 2 is equals to n minus 1. Here minus will get cancelled. Then we remains with n minus 1 is equals to 29 by 2. Now here also 29 by 2 will become a decimal point, not a natural number. So n value does not belongs to the natural number. Then this minus 25 is not a term of the given arithmetic progression. Next question. How many multiples of 3 lie between 20 and 50? So we have the numbers 20 and 50. In between those, how many multiples of 3 will be there? These are the numbers from 20 to 50. In this question particularly he is asking multiples of 3 only. So 3 table we need to check once. 20 won't come in 3 table. 21 will come in 3 table. So starting from 21 onwards. 21. Then next number will be plus 324, plus 327 and so on. Then what will be the last number? 50. 50 won't come in 3 table. 49 won't come in 3 table. 48. Yes, it will come. So the last number will become 48. So starting from 21 to 48. 21, 24, 27, 30, 33, 36, 39. If we keep on adding 3, 3, 3, 3, 3, we need to check how many numbers are there like this. So the formula is nth term formula. An equals to a plus n minus 1 into d. Now if you observe this clearly, here the last term is 48, right? That will become an is equals to a value 21 plus n value we need to find out. Common difference, we are finding the multiples of 3, right? So then common difference will be 3 only. Of course if you want you can find out from second term minus first term also, you'll get MCM value anyway. So this 21 take to the left side. 48 minus 21 is equals to n minus 1 into 3. 48 minus 21, 27 is equals to n minus 1 into 3. 3 ones are 3 nines are. N minus 1 is equals to 9. Now take this minus 1 to the right side, then it becomes a plus 1. So n is equals to 9 plus 1, nothing but 10. So it means starting from 21 to 48, total 10 numbers will be there. It means 3 multiples are 10 in number between 20 and 50. Next question. Find the sum of n terms of AP 3, 6, 9 and so on till 22 terms. Sum of n terms, we have one formula. Sn equals to n by 2 into 2a plus n minus 1 into d. So Sn, right, that is 22 terms he is asking, so n value will become 22. Let us substitute in the formula now. N value 22 by 2 times 2 into a value, first term, that is 3, plus n value 22 minus 1 into d, common difference. So here second term is 6, first term is 3. 6 minus 3, it is 3. Let us simplify this calculation now. 2 1s are 2 11s are 11 into 2 3s are 6 plus 22 minus 1, 21 times 3. That is equals to 11 into 6 plus 21 3s are 63. That is equals to 11 into 6 plus 63, 69. So what is the value of 11 into 69? 69, 69, 9, 5, 759. So the sum of 22 terms of the given progression is 759. Coming to the next question. If the sum of 1, 3, 5, 7 and so on till n terms is 169, then find n value. So 1, 3, 5, 7, 9, 11, 13, if we continuously extend those, the sum is 169. We need to find out how many terms we need to add like that. The same formula as usual. Sn is equals to n by 2 into 2a plus n minus 1 into d. So here n value we need to find out, right? So n is unknown number, so write n as usual by 2 times 2 into a value 1 plus n value don't know into common difference 3 minus 1 2. So let us simplify this and we will get to know the value. Now here he said clearly that sum of all these numbers is 169, right? So Sn will be 169. 169 is equals to n by 2 into 2 1s are 2 plus plus 2 into n, 2n minus 2 into 1 2. This plus 2 minus 2 will get cancelled. So 169 is equals to n by 2 into 2n. This 2 will get cancelled. 169 is equals to remains with n into n. So n into n is nothing but n square, right? So n square is equals to 169. N square is 169, then what will be the n value? Plus or minus 13, because 13 is 169. Then n is nothing but number of terms. Number of terms will be always a natural number only. So finally n value will be plus 13. So total 13 terms if we take like that, then the addition will be equals to 169. Next, if an, that is nth term, is equals to 2 plus n, then find the arithmetic progression. An is given as 2 plus n. That is general term or nth term formula. Now I am going to find out the first term. So n equals to 1. A1 equals to 2 plus 1, that is 3. Then I am going to find out the second term. A2 is equals to 2 plus 2, that is 4. Then coming to the third term, A3 is equals to 2 plus 3, that is equals to 5. Then he is asking to write as the arithmetic progression, right? So first term is 3, comma, second term is 4, comma, third term is 5, comma, and so on. This is the arithmetic progression. Next, if Sn is equals to 2n plus 1, then find arithmetic progression. You need to be very careful in between these two questions. Here an is given, that is nth term. Here Sn is given, that is sum of the n terms. So just be careful with these two type of questions. Now let us check this Sn once. Sum of the nth terms is given here. Sn is equals to 2n plus 1. Now I am going to find sum of the first term or else one term. 2 into 1 plus 1 2 ones are 2 plus 1. 2 plus 1, it is 3. Next, I am going to find out sum of two terms. That is 2 into 2 plus 1 is equals to 2 2s are 4 plus 1, that is 5. Now, one small logic we need to use here. Sum of the one term. What exactly it means? In the total progression, only one term is there, then that only will become the sum of the progression. Right. So, this S1 is also considered as first term or A1. Then what about this S2? S2 is nothing but sum of the two terms, right? So, 1, 2. Two terms are there. We don't know both the terms. This first term just now we got it as 3. So, in the first term 3. These two terms, if we do addition, we need to get the answer 5. That is sum of the two terms is 5. So, what will be the second term? Then obviously that should be 2 compulsory. So, second term will be 2. Then how we will write that one as? So, second term, that is A2 is equals to sum of the two terms minus sum of the one term. That is 5 minus 3, which is equals to 2. So, A first term is 3, A2 is 2. So, let us write this progression now. First term is 3, comma, second term is 2. Obviously, if two terms are there, means later all the terms we can write. 3 minus 1 is 2, right? So, 2 minus 1, 1, 1 minus 1, 0, and so on. Find distance between the given 2 points 3, 4 and minus 1, 2. So, we have a formula to find out the distance between any given 2 points. The formula is under root x2 minus x1 whole square plus y2 minus y1 whole square. Now, in the given points x1, y1 and this is x2, y2. So, let us substitute in the formula now. Under root x2 is minus 1 minus x1 is 3 whole square plus y2 is 2 minus y1 is 4 whole square. So, let us simplify this further. Under root minus 1 minus 3 minus 4 whole square plus 2 minus 4 minus 2 whole square. Under root minus 4 square 16 plus minus 2 square 4. So, that will be equals to under root 20. So, the same under root 20 can also be written as 5 fours are under root 4 into 5. Root 4 is 2. Root 5 as it is 2 root 5 units. Next question. If the distance between 1, 2 and minus 3, p is 4, then find the p value. So, the same formula again under root x2 minus x1 whole square plus y2 minus y1 whole square. But this time in the question only he gave clearly that the distance is 4, right? So, make it equals to 4. Now, if we observe this clearly, left side we have square root, right? So, to remove that square root, I am doing squaring on both the sides of the equation. So, that square root and square will get cancelled. Now, finally, we remains with x2 minus x1 whole square plus y2 minus y1 whole square is equals to 4 square, that is 16. So, now let us substitute. This is x1 y1 and this will become x2 y2. So, here x2 is minus 3 minus x1 is 1 whole square plus y2 is p minus y1 is 2 whole square, that is equals to 16. So, if we simplify this further, minus 3 minus 1 is minus 4 whole square plus p minus 2 whole square is equals to 16. So, minus 4 square 16 plus p minus 2 whole square is equals to 16. So, this p 16 will get cancelled. Then finally, we remains with p minus 2 whole square is equals to 0. If p minus 2 whole square is 0, then what about p minus 2? That is also 0 only. Take minus 2 to the right side. So, p is equals to plus 2. Next, Find the midpoint of the points 2 comma 3 and minus 1 comma 6. This I am taking as x1 y1 and this I am taking as x2 y2. So what is the formula for midpoint? x1 plus x2 by 2 comma y1 plus y2 by 2. So just we need to substitute those numbers in this formula. Let us substitute now. x1 is 2 plus x2 is minus 1 divided by 2 comma y1 is 3 plus y2 is 6 divided by 2. So let us simplify this now. 2 plus into minus minus 1 by 2 comma 3 plus 6 9 by 2. 2 minus 1 1 by 2 comma 9 by 2. So the midpoint of the given points is 1 by 2 comma 9 by 2. Next, if the midpoint of minus 1 comma 4 and 0 comma k is minus 1 by 2 comma 6, then find k value. So here also is speaking about midpoint only. So then write the formula x1 plus x2 by 2 comma y1 plus y2 by 2. So this is x1 y1 and this will become x2 y2. So let us substitute in the formula now. x1 is minus 1 plus x2 is 0 divided by 2 comma y1 is 4 plus y2 is k divided by 2. This is midpoint, but according to the question the midpoint is minus 1 by 2 comma 6, right? So make it equals to minus 1 by 2 comma 6. So whenever you are equating the coordinates like this, this is x coordinate and this is y coordinate, right? So here also this is x coordinate and this will become y coordinate. So whenever if you are equating the coordinates, x coordinate will be equals to x coordinate only, y coordinate will be equals to y coordinate only. And in this question we need to find out the k value. So if you observe the x coordinates, in x coordinates alphabet k is only not there. In this one or else in this one. In the x coordinates alphabet k is not there, so no need to worry about the x coordinates. You can leave it completely. Now y coordinates, if you observe, 4 plus k by 2 6. So here k value is there, so that's why making y coordinates equal to each other. That is 4 plus k by 2 is equals to 6. Now we need to find out the k value, so further take 2 to the right side. So what it will become then? 4 plus k is equals to 6 2s are 12. Take 4 also to the right side. K is equals to 12 minus 4. Then k value will be equals to 8. So k value is 8. Next, find the centroid of the 3 vertices of a triangle where the vertices are 1 comma 1, 2 comma 3 and minus 1 comma 4. So this I am taking as x1 y1 and this as x2 y2 and this will be x3 y3. So what is the formula for centroid of a triangle? x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. So simply let us substitute in this formula now. x1 is 1 and x2 is 2, so 1 plus 2, x3 is minus 1 divided by 3 comma y1 is 1, y2 is 3 and y3 is 4 divided by 3. Let us simplify this now. Plus 1 minus 1 cancel, then remains with 2 by 3 comma 1 plus 3 4, 4 plus 4 8, 8 by 3. So the centroid of the given points is 2 by 3 comma 8 by 3. Next question. If the centroid of a triangle is 1 by 3 comma 4 of a triangle whose vertices are given as minus 1 comma 2, 2 comma k and 0 comma 4. So these I am taking as x1 y1 and these as x2 y2 and these as x3 y3, and he gave the centroid as 1 by 3 comma 4. So let us substitute in the formula now. The formula for centroid of a triangle is x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. Let us substitute now in this. x1 is minus 1, x2 is 2 and x3 is 0 divided by 3 comma y1 is 2 and y2 is k, y3 is 4 divided by 3. According to the question, the centroid is 1 by 3 comma 4, right? So make it equals to 1 by 3 comma 4. Now here also both the coordinates we are making equal, right? So this x coordinate will be equal to the x coordinate only. Y coordinate will be equal to the y coordinate only. Now if we observe the x coordinates clearly, in the x coordinates, alphabet k is not there at all. So no need to worry about the x coordinates. Let us make the y coordinates equal to each other. That is 2 plus k plus 4 divided by 3 is equals to 4. So making the y coordinates equal to each other. Let us simplify this now. Take this 3 to the right side, then it will become multiplication. 2 plus k plus 4 is equals to 3 4s are 12. 2 plus 4, 6 plus k equals to 12. Take 6 to another side, then it becomes minus. So k value is 12 minus 6. So 12 minus 6 is nothing but 6. So k is equals to 6. Next one. If the point P divides a line segment 0, 4 and minus 1, 4 in the ratio 1:3, then he is asking to find the P value. So we have a one line segment like this, that AB line segment. Point A is given as 0, 4 and point B is given as minus 1, 4. And on this line segment somewhere we have one point P. This P is dividing the total line segment in the ratio 1:3. Then he is asking to find out the point P coordinates. So for this one we have one formula, that is section formula. This as usual we will take it as x1 y1 and x2 y2 only. And this ratio we will take it as m1 m2. So the formula, that is section formula, is m1 x2 plus m2 x1 whole divided by m1 plus m2, comma m2 x1 plus, sorry, y will come right now because x completed here, m1 y2 plus m2 y1 divided by m1 plus m2. Now let us substitute in this as usual. So here m1 is 1 and m2 is 3, right? So m1 is 1 into x2, x2 is minus 1, plus m2 is 3 into x1 is 0, divided by m1 plus m2, that is 1 plus 3, comma m1 is 1 into y2 is 4, plus m2 is 3 into y1 is 4, divided by m1 plus m2, 1 plus 3. So now if we simplify this further, 1 into minus 1 plus 3 into 0 0 by 1 plus 3 4, comma 1 4s are 4 plus 3 4s are 12, divided by 1 plus 3 4. So if we simplify this further still, minus 1 plus 0 minus 1 divided by 4, comma 4 plus 12 16 divided by 4. If any simplification is possible, we need to do that one. Minus 1 by 4 as it is, comma 4 1s are 4 4s are, so 4. So the point, I mean P is there right in the middle. This point P coordinates are minus 1 by 4 comma 4. So P point coordinates are minus 1 by 4 comma 4.